differential settlements, most of these are fundamentally geotechnical in nature. These are not hypothetical scenarios, but real risks that threaten lives, infrastructure, and economic stability. If we are serious about climate resilience, disaster risk reduction, or sustainable infrastructure, geotechnical engineering must become a central part of our planning conversations. And this is why today's seminar is so timely and so valuable. This event brings together experts who are willing to share their knowledge on topics that are essential to building safe, resilient, and proper infrastructure. More importantly, it opens the door for those who are less familiar with geotechnical topics to ask questions, gain exposure, and build interest. Whether it's understanding soil behavior under dynamic loading, the role of groundwater in slope instability, or the design of foundations in soft or problematic soils, these discussions are meant to inform and empower. But most of all, we want to inspire. We want young engineers to consider the geotechnical space as a rewarding and essential career path. We want public agencies, private developers, and others to appreciate the value of proper site investigation. We want to grow a culture of technical excellence that acknowledges the full depth of engineering and not just what we see above ground. Having said all of this, I want to thank each and every one of you for taking the time to be here today. I would like to thank our presenters, Charles Allen, Luis Velez, Angel Andalos, and Helber Gutierrez. I would like to thank our sponsors, Smith Warner International, Consulting Geotechnical Engineers, Geolabs, Tensar, and our endorsers, the Jamaica Institution of Engineers. Thank you. Your presence is a signal that geotechnical engineering matters and that we are ready to pay more attention to the ground that we build on, both literally and figuratively. Let's take full advantage of today's presentations. Let's ask questions, share insights, and continue the conversation beyond today. On that note, I officially welcome you to today's seminar. And without further ado, I'd like to introduce the CEO of Smith Warner International Limited, Jamel Banton.
Good morning, everyone. Loud enough, I guess, definitely. All right, thank you, Vicky. Thank you, everyone, for coming here. This indeed is the kind of gathering we were hoping for, because this is a important topic to discuss. I've been told by some of my friends who are still in the dating game that breakfast dates are now better than dinner dates. Apparently, it's cheaper, and if you can tolerate somebody before coffee, then you could tolerate them after. I'm happy we're doing this over breakfast, rather than sometime later in the day. So first, I'd like to thank the JIE for endorsing this event. I think it's a great opportunity for knowledge sharing, as Vicky said. As engineers, sometimes we don't share enough. We don't learn from each other. We should always be learning. That is how we grow. So, excellent move by Jay to endorsing and being a part of this. How did we get here? Many of you know Smith Warner International as coastal engineers. What a lot of you don't know is that we started construction 20 years ago. So we've been doing as much construction as design. And my last presentation to this kind of crowd was on the work we were doing on the St. Thomas Highway, on a leg on the St. Thomas Highway, not all of it. Um, so we've gone from beach construction, shoreline protection into actually civil construction. But part of that construction is piling, and we've actually been doing a few piling projects in Turks and in in here in Jamaica. And it's in doing that we recognize that maybe there's space for some more geotechnical engineering, and I'll start there. But we're calling it foundation engineering because we wanted to appeal to everyone, and everyone needs to understand it's about your foundation, and everybody will know that you need a good foundation in life. So um, it's in exploring that we realize that there is space. I mean, nobody else would than me would love to acknowledge that there have been good geotechnical engineering in Jamaica, but certainly there's space for somebody else to contribute to the field. So another thing I'd like to just touch on is engineering ethics. I would like to again applaud the JIE for the there's a workshop this week on engineering ethics because that's important, and especially in this day and age where everybody uses AI, or everybody. I know my wife is a doctor and she complains about the Google Docs. You know, people research this and all of a sudden they are experts in something. I remember years ago we worked on a project somewhere in the Eastern Caribbean, and we were subs to another engineer, and we gave them the drawings, and a few months later we didn't hear from them. A few months later we saw the drawings on their letterhead, their title block, the whole thing submitted to the client, and no mention of Smith Warner. They claim the work as their own. And it is for this reason and our own emphasis on quality that we decided that we needed a partner, and a reliable partner, and a very good geotechnical engineer. And that's why we partnered with Charles Alling and his CGL team to do this. So it's not just Smith Warner's coastal engineers doing this, but we're offering this with solid expertise and experience in the business. No, Charles is actually a Jamaican. He's one of those Jamaicans who went to Trinidad and ate that fish. You know that fish when you eat it, you don't leave. Cascador. He's Jamaican, but he's based in Trinidad. So, Tensar, we also would like to thank you as a partner. We've used your product on some of our construction projects, so we're excited to hear all of what you'll certainly present to us. And it's kind of funny that I am now operating in the space of that we all have a lab as Vicky mentioned, because I remember back in the day in Trinidad, our soils mechanics labs was on a Friday morning, and these hermits in there would understand. But it so happened that Thursday night, Julian would tell, Thursday night would be coconuts. That's the club we used to go to. So there was a particular girl in my class where she just was always in my business. I don't know why she liked me or she hated me. Um, and so this Friday morning, Thursday night was probably a little bit rough coming from coconuts. So I missed Soils Lab. And as hermits, hermits would normally just write down your name because you go there and the routine was you write down your name. If you're there, if you're not there, and your name is not on the list, then the teacher would know. So the guys came home and say, Jamel, you're in trouble. You're absent. I'm like, what do you mean I'm absent? I didn't go there. I didn't, whatever, know my name. So apparently this young lady wrote down my name and put absent beside it. So so that's my memory of soil mechanics lab. So, but such is it. But on a serious note, I'm very serious about our engineering fraternity and how we do business and how we spread our wings throughout the Caribbean, not just in Jamaica. So I've been a part of several um, large projects, and I'm always saddened when I'm in a meeting room and all the consultants are from elsewhere outside of the Caribbean. When I know I have very good consulting engineers representing all fields who are here from the Caribbean. So I'd like to encourage all of us to spread our wings and to grow as much as we can. So thank you all for coming, and I hope this session will be fruitful for all of us. Thank you very much.
All right. Thank you for that, Jamel. So our first speaker today, Charles Allen. I'm very excited to introduce him. He is the managing director at Consulting Geotechnical Engineers Limited, and as Jamel had mentioned, they are our partners in this new area of civil engineering that we've decided to undertake. So Charles Allen is an accomplished and experienced civil geotechnical engineer with over 20 years of experience. His career has been marked by a strong skill set in deep foundations, slope stability, civil engineering, foundation design, road pavement design, quality assurance and quality control for airport pavements and other aspects of civil and geotechnical engineering. Over the past 4.5 years, he has led his team at Consulting Geotechnical Engineers Limited in Trinidad. Prior to this, Mr. Allen served as director at Earth Investigation Systems Limited for 19 years, where he established himself as a geotechnical engineering expert. He has worked extensively throughout the Caribbean. Today, Mr. Allen will be presenting on lessons learned from geotechnical failures due to inadequate site investigation. His focus is simple but crucial: understanding how and why geotechnical failures happen and how we can prevent them. Ladies and gentlemen, please join me in welcoming Mr. Allen.
Pleasant morning, everyone. To the JIE, Mr. Porter, thank you for being here. To members of faculty, very important, Dr. Smith, Dr. Ellis, my good friend, used to be in Trinidad, like doubles. And to fellow engineers and most important for me, engineering students. The privilege is mine. I'm honored to be home and to also to share some of the experience that we are doing in Trinidad and the Eastern Caribbean and in Guyana, more so on understanding failures and the lessons learned that we can get from these projects. And we want to go through some learning outcomes for what we want to do today. It's a lot of information, and I'm going to try. Some areas I'll be going a little fast, and I'm going to be focusing in on the more important things that I would like you to leave with you as you leave here as engineers, and the importance of what we do and why we do it. But before I move on, Herbert has always been very respectful to our female engineers. And in keeping with yesterday, International Women in Engineering, we'd just like to give a round of applause to our female colleagues and to recognize them for the effort. I want to say thank you, to support them at the career, all team members, right? And you learn about CGL in a minute, and you'll understand why I say this. Victoria, as part of our team, I want to thank you for your effort over the last couple of months. She has been working very hard. To my friends from Tensar, These guys are my colleagues, my friends, Angel, Luis. We've been working together for over 15 years, 12 to 15 years, on major projects. And they are people who are of integrity, always willing to give you guidance on finding the right solution, obviously at the right cost. Right? And one of the reasons why I invited them to come over to be part of this is to also share with you the latest in the technology and how we can help to reduce engineering costs as we develop these large sites or infrastructure projects and also for foundation. So I have a little minute what the guys prepared for me about the company, and I don't want to cut it short, so they'll be upset because they're watching online. So topic today is lessons learned from geotechnical failures. So we want to understand what is a geotechnical failure. Let me see if I can play this. That side today. So this is our team. I guess it's not connected to the sound, so I can't. Could do that, Victoria. All right. We'll go back to that. So the learning outcomes for today is that we need to understand what is geotechnical engineering, the difference between the broader subject of geotechnical engineering and foundation engineering, and the role of the geotechnical engineer. This is very important. But the main focus today is really the importance of site investigation, why it is critical to every civil project. Right? We want to understand how we arrive at geotechnical parameters, the models that we use to carry out our design, and the minimum requirement. One of the trouble that we always have is the lack of scope when engineers try to get a geotechnical investigation done. And there are some documents I'd like to share with you guys that will help you to write a proper specification for a geotechnical investigation. That's critical. And then we talk a little bit about the cost. So geotechnical engineers don't just do boreholes. We are design engineers, right? So we won't be able to cover the full process of a site investigation. But we want to look at some case studies that, will help us to understand each category, how we get to number 5. I do a lot of number 6, which is field verification, testing in the field, whether to pile testing, plate load testing, to verify some of the design models that we use, right? So before we continue, can I see the hands of those who have ever read a geotechnical report without falling asleep? Right. So most times people just turn until they find the bearing capacity and settlement. They don't read the report, right? They don't understand why we record water table, the impacts of that, that type of thing. So we want to clear up some of those things today. Why you need to read the report. First thing you get up in the morning, as you drink your coffee, you grab the report. I understand that sometimes a little bit challenging, but we want to go through and show the importance of why we spend time to do these things. So what is a failure? I could talk to you today about over 30 projects, what we call major failures, right? So look here, somebody wake up in the morning, look through the bathroom window, and see a building coming down on the property, right? Right? So there's a townhouse development, 2 terraces down, and we can see one block that the contractor did moving at a rate that we had to do something to kind of stop it. And this is a private development, not a government project. So we had to solicit the army, right, Romain, to come in to help us. So those cables are tied to some major anchor blocks that were used to hold the building in place while we demolished it as fast as we could, right? So I just did a little cartoon there to show you that NWC pipe right there. Sorry, WASA pipe. Right, same thing. You know, don't matter where you are, Wasco, St. Lucia. So sometimes a lot of people, a lot of hillside development is taking place across the Caribbean. You see what is happening in Trinidad and Jamaica and other Caribbean islands, major hillside development. And so everybody wants to drive onto a platform that is right onto their property or their building. But engineers need to understand that without a site investigation, in this particular case, the contractor thought he knew what bedrock was. Nobody considered the water pressure if the pipe in the road burst. And that's what happened. The active pressures, the water pressure build up in the fill and push down the building. Right? So these are the things that we need to check. The design consider all earth pressures in saturated conditions. Was that considered? None of these things were taken into consideration. And then we can see and understand what implications could have occurred. Life and limb we're talking about, right? When we talk about geotechnical failures, we talk about in foundations, we talk about limited movement to the tune of millimeters, 1 inch maximum. But when you're dealing with Mother Nature, right, we're talking about sometimes movement hundreds of meters. This is one of the largest landslides I've ever worked on. It's 1/2 kilometer in length, 500 meters. And the width of it is almost 350 meters long. Right? And I could spend the whole day talking about this project, but looking at that house has moved 30 meters downslope. And it's the hand of God that saved this family, because Mr. Garcia, the husband, got up in the night to use the bathroom at 3 o'clock. He went to the bathroom and realized the door couldn't open. When he looked in the kitchen, all the tiles started to pop up off the ground. He just got enough time to wake up his family, jump in the car, try to reverse. The van dropped in the tension crack. He had to push it, and he reversed out the vehicle, and then the house went down the slope with it. The landslide eventually receded and took all those houses at top, as you can see there. This is an area that is called in Claxton Bay, where the geology here is called the Stumsum Hill Sands, red sand. And there is a quarry 150 feet away where the contractor dug vertical cliffs to 30 meters deep, below, even 3 meters below sea level, unregulated. And one day after torrential rainfall. So in this case, I was the independent expert for the court. And as engineers, if you want to test your metal as an engineer, go and sit in front of 6 lawyers and see you have what it takes. Because they will know design codes better than you. So that's why I say you have to put in the work to understand what is required. So what is geotechnical engineering? Right? So geotechnical engineering deals with analysis, design, construction, maintenance, and renovation of geotechnical structures. It's really 7 categories that it covers. And we want to show you examples of each. Major one being foundation engineering. And there's a difference, right? So what is a foundation? We know it's basically broken up into 2 categories, shallow and deep foundations. And the goal of a foundation is really to, that structural engineering part of the engineering system, right? That is below the ground at some depth. And it has to adequately, safely support the weight of the structure itself and transmit that load to the ground effectively without any major movement, right? Soil mechanics, the foundation 101, remember this, guys? You pass the course or the fail? You know, Dr. Gay, a difficult exam to pass, right? So a shallow foundation, right, is where the width B is much greater than or equal to the depth of embedment below the ground surface, right? Whereas the opposite is true for a pile. So at this point, I want to give you guys a little exam question, but time doesn't allow. But surprisingly, we had to do all these things by hand calculation. I could put that question right now to chat GPT. I don't want to be a student now. It takes the fun out of it, right? 1 minute, you get an answer, right? But whether it's correct or not, you don't know, right? So another term that's used a lot in our field is now geotechnical earthquake engineering, critical. And you start to see things about seismic site response analysis, spectrum, site class, what is a site class, soil structure interaction, liquefaction, big topic, right? And that's a word I do not put in reports very likely. I rather talk about liquefaction potential than liquefaction. When people use the word liquefaction, read the report, oh my God, the whole site is going to liquefy and suck the building under the ground like the giddy house. Far from the truth, right? It's really a statistical analysis that we do to measure risk or the likelihood of a site or parts of a site that may or may not liquefy, right? So it's a risk analysis. So we have to be very careful when you read a report that the man said the site can liquefy. Sometimes that's not the case, right? And it basically affects the project in moving forward. Then engineering seismology, you do a little water, hydraulics, environmental, highways and stuff, and also some structural engineering, right? And that's geotechnical engineering itself. So what does a geotechnical engineer actually do, right? So they provide models, parameters, and verification services that might facilitate design and construction of earth and earth-supported structures to maintain their functional integrity over its design life, right? And design life could span 50 years, 75 years, depending on what you're designing for, right? I won't talk too much about this. We'll stick with allowable stress design methodology, where we have a global safety factor. Remember that, guys? Factor, Kenneth, 3. Remember that? Good. If we go, not pi, but yeah, all right, sorry. LRFD design is a little more complex with partial factors of safety and all these type of things, but you guys can read the code in time. But these are very important failure modes and failure philosophy of how we carry out geotechnical design. So the projects are really broken down into these categories, and we're going to go through them so you guys will understand clearly what types of foundations are used under these structures. Tanks, we do a lot of these. Oil tanks, condensate tanks, a lot of tanks in Trinidad, given the oil and gas sector. And you can see how we normally do it. It's a ring beam foundation, and we have quality control testing to fill. And there are serious requirements in terms of even getting on the site because you have a lot of hydrocarbons, and the rig has to be special purpose in terms of spark arresters. You can't have a spark inside a oil facility. And more importantly, we can't have any workers who have no form of drugs in them system. So madam who smoke marijuana can't work for us, right? And we spend a lot of time on training, use of these drilling rigs, because safety and insurance in this sector is critical. You pay a lot of money just to even work on these projects. So, and then you can have an idea of what the parameters we have to provide in terms of running the analysis for a tank foundation. Allowable bearing capacity, total settlement, differential settlement, subgrade modulus, stiffness. These things might look new to you guys, but we can't get any of these things without a borehole or two, right? And lab testing. Building, pad footings. You guys are accustomed to seeing pad footings. The spacing, this is the hospital building, yes, done by China Railway. But a 5-story hospital designed to a much scrutinized or seismic category than a normal structure. And we have to provide all these things and check settlement over the building footprint. Pile caps, very important. Connected by ground beams. So this is what a pile cap would look like in terms of the construction of it. And then we go to raw foundation. And this is something that we are doing a lot of because we have a lot of clients, especially in Trinidad. If I mention the word pile to them, I get fired instantly. Right? They don't want to hear anything about piles. Too expensive to mobilize equipment, etc. So what we do, we modify the ground to suit the foundation that we want to use, right? In this case, this is the tallest apartment building I did a couple years ago in San Fernando. And I show this picture because right now we're doing an investigation for a 6-story hotel, another Hilton hotel in San Fernando. And, you know, a typical phone call from this particular client would go like this. Chalo, I do the next building next door. Remember you saved me some millions next door. I put that part in. But you remember the project next door? Can you just look at the ground and tell me what I should do for this new building? Just do a 1 borehole. I said, nope, can't do it. 2? Nope. 3? No, sir. 4? All right, we'll work with that. Send a mobilization invoice. There's always a negotiation that clients don't want to do a site investigation. And I'm not willing to take that risk. Because when you spend millions of dollars investing in a building like this, and you want to spend some change on that risk, I'm willing to walk away from the project. Right? But but some clients know that they like to push the limits, right? Because it's always a risk when you know what failures can happen. This is one of our present housing projects, 32 4-story apartment buildings. And this client, same client I'm talking about, we have to at least be at 4 raw foundations ahead of his team. They use the Colombian Forza system, and they can put up this 4-story building in 1 month. And they're coming pretty fast. So we have to always be ahead in terms of the foundation. Now, my agreement with this client in particular is that if I can save you from using piles, I have full autonomy in the quality control and management in the construction site. So I spend a lot of time in the field making sure that we modify the ground, compact it in layers, check settlement, monitor the guys to get what I want for him to be satisfied and for him to also pay me on time, right? So sometimes the client have to understand that you can modify things to get what they want, but they understand that quality is critical. You remember this diagram? I point this out to you because stress distribution is related to the load and the footing width, right? Remember what Terzaghi, and I'm not sure if this thing has a pointer, but that triangular shaded block right below the footing, once that footing is loaded to failure, it moves down and it pushes out those 2 blocks of soil and pushes the upper 2 blocks above it. So creating that failure plate if you carry a footing to failure, right? And for a square and strip footing, you can see both in the pressure bulb theory where the stresses, how they are distributed below ground, right? And it's in relationship to the actual footing width. Very important to understand that. So clients say, well, cut the cost now. I don't know, guys, but if somebody could tell me how the negotiation goes with a structural engineer and his client, so well, take out 2 column and a beam now, I will secure the price, right? You understand? So this is what I have to go through every day to explain to clients, and it's simply the mere fact that out of sight, out of mind. Nobody sees your work, but they don't understand the importance of why the foundation is critical because they just don't see it. So let's take a typical warehouse structure. We could take any line in terms of the distribution of the loads across the building. And we're required now to have these structural ground beams for seismic design. And then we can now produce a stress distribution model below the footing so we can see what footings are loaded, where the stresses are, measure deflections, settlement, and all these things, right? From these models. These finite element models, you can do a lot of things with it. But like anything else, garbage in, garbage out. All right, Kenneth, what is wrong with this picture? Who wins? Who wins? The only person that winning here is the piling contractor. 80% of the piles never reach the required depth. but the client is unwilling to spend $20,000, 1% of what he's lost, to investigate the site, to save all that concrete. The main contractor has to cut every single pile and dispose of it. You know how long that takes? The cost, the time, right? So we need to understand, right, for piles, what type of pile system you want to use, right? So here's a pile. It's a Delmag pile driving rig. And when you count the blows, you can hear it or visualize it. Not very long video. Just keep your eyes on the pile. He didn't pull any more load or any more blows from the hammer. Pile is still moving. So this pile is about 90 foot long. And it continues like that until about 65 feet. Right? You try to design a site in a swamp and you have conditions like this. And you're spending 25 million Jamaican dollars to mobilize that crane alone on a site to do this type of work. I just don't understand the math where clients don't understand that the cost of the investment of doing investigation as compared to mobilizing equipment. It just, the maths don't work, right? So we have a lot of CFA rigs in Trinidad as well for deep foundations, and we lateral models of subgrade reaction is a very important item that we need in terms of the analysis, the shear strength, Andrean shear strength, if it's clays, how we analyze these types of piles. And here we have the pile models in terms of the spring system that we can use to model it. And, you know, for a long pile, the PY curves, where they have a moment at the top, a lateral load, and the axial load on the pile, and how you analyze single piles, and we can also do this for group interaction as well, right? What I love is that based on certain size projects, I can get to test my calculations with real life loading conditions. So here's a bench that we have that we can load up to about 355 metric tons. That's about 29 JUTC buses piled on top of each other. So here we have two axial pile tests, one that failed. Sorry, I do have the pointer. As you can see, that plunging line suggests that we load the pile to failure and it just continues to go at around 2,500 kilonewtons. Whereas this pile is 20.7 meters long on a different site, a CFA pile, where we test the pile up to about 3,345 metric kilonewtons. And then from this, the more pile tests you have on site gives you the ability now, because you have more reliable data, to actually reduce the factors of safety that we talk about in the low stress design. So I can now give the clients option in terms of maximizing the efficiency of using less piles because I have data, right? So all this is tied back now into the design, the final design. Lateral loaded pile, right? We do a lot of these tests as well, where we do a cyclic loading, unloading, 2 cycles. And then you can have 2 methods where you can actually work out from the IBC or the double tangent method. You can actually work out what the allowable lateral load on the pile head can be, right? Especially if you're piling close to slopes, you want to know that the pile can withstand that lateral movement you want to put on it, right? So field verification is very important, and I'm hoping that in Jamaica we get to the stage where engineers can verify some of the data and create that data set that engineers can use. I said this to also say that in Trinidad we have about 5 geotechnical companies, all local, no foreigners. And we don't compete. Yes, we might compete on price, yes. But if one geotechnical firm has a problem, well, they always come back to Dr. Gay, right? But we always try to work together. If a piece of equipment break down, come by me, no problem. We work out something. Because at the end of the day, the value in this is building the practice. And I value building the practice more than dollars and cents. Right? So 60% of the failures that we have to deal with every day is retaining walls. I'm going to look at some of them. I'm going to talk about a very important one, which is a bridge failure. So remember the modes of failure for a retaining wall. I mean, I didn't want to bring it up, but I would like, COVID did not do justice to some of our engineers. In that, we have some graduates who came out with a civil engineering degree and don't know what a retaining wall is. I kid you not. Right? So for our younger engineers, if you want to be good at your craft, you have to put in the work. Right? Ask the questions, do the calculation. Don't ask ChatGPT. Right? Do the hand calculation. So here is a wall in January on the highway. As you can see, the wall is separated and it's moving down slope. The government drove sheet piles to protect the highway. In 2 weeks, sheet piles were flat on the ground, and the wall went down the slope. When we investigated it, we realized that the contractor backfilled the retaining wall with slope, with clay, highly expansive clay. Half was done in sand, and the other half at the joint, from there down, clays, no drainage. And this was done by the ministry. So I say this to say that your design is just as good as the construction quality, and drainage is key to our retaining wall infrastructure. NWC, sorry, WASA. For retaining walls where pipelines are in the road and they leak, right? Remember, water does not flow up. So when you see water coming out of the road, it means everything below is saturated, right? Sometimes you cannot design. These are retaining walls on 400 millimeter diameter auger piles staggered at 1.5 meter spacing, 12 meters deep. These walls cost millions of dollars. And in one pipe leak, that's it. Right? So we have to now come up with a solution. A simple one that we did was that I've designed an over-designed box drain with a strap on it, metal strap, and strap the pipes to the box drain so that when the pipe leaks, you can fix it, one. And two, if it leaks, it go in the drain. The water company fight that, they're using it all over the place. Right? Common sense, not so? So we have to be careful with the whole infrastructure, for these types of retaining walls, reinforced concrete walls. We have other types of walls, Allen block retaining walls, and most clients would listen to their contractor over the engineer. You want to build a 30-foot wall with a system that cannot take that type of lateral stress. And these are the outcomes, right? And then we get called. And a matter of fact, this is the second wall he built. Right? More so in the Caribbean, as our infrastructure age, scour. Retaining walls along riverbanks, scouring the foundation. Nobody checks, nobody maintains anything, so nobody is checking to see how we're going to treat with these types of failures. And then we have a tendency in the Caribbean to kind of creep to get more land as much as we can on the riverbank. And these are sometimes the consequences. That is the man falling down in the river there, and his building collapsed in the back. I just put in this slide to show you that we do a lot of different types of retaining walls. This one is called a flex MSC wall. No concrete, fully vegetated wall with these bags wrapped in a uniaxial geogrid. And we put plugs in the bags with, I think it's 30% organic with sand. And you put the plugs for the plants you want to grow. And in 2 weeks, that was the outcome. Right? Ready rock walls. I don't know if you guys have seen these. We have done about 4 of them in Trinidad. Like a Lego. Right? Male and female connectors. And you just bring the We have the molds in Trinidad, and we just bring the blocks aside. This one is a gravity wall, but these walls are designed, these blocks are designed with a full geogrid connection. Can go up to 13, 14, 15 meters with this. The XL blocks, you just need the excavator to put them in place. The base blocks are 1.5 tons. And you can now design them how you want and run your same analysis to see how you get these walls, right? To stand up. And it looks pretty good. This wall is a 6-meter wall. And then we have crib wall, major in the mountains. This one is 10.5 meters tall. Going down to Maracas where you buy bacon shack. This landslide occurred and took away the entire road. We had to put a bridge over the road for people to get home. And we had to build this wall. We actually supervised this one. Pretty decent. So designed by our engineering manager. Right. Abutments are part of this retaining wall system. This is a job I assisted Dr. Gay with many years ago, and the bridge still not moving today. The new bridge about 45 meters long, and you can see disparity between where one abutment is and where the other one is in relation to the riverbank. Right? Because the engineers were constrained by where the roundabout is on the south side of the bridge. So they had to push the bridge up. As you can see, where this gentleman is standing, you see that crack going right through the embankment. That's us trying to do our investigation to figure out what's happening. The entire abutment was moving. And if you realize something else, what is on the bridge? Live traffic. Right? So, you know, things go politically. Sometimes you have to do what you have to do to get things done. So the free end of the bridge was moving to the other side, and it ripped the anchor bolts out of the other abutment and punched through the other side of the abutment. That's how high the stresses were. Right? The engineers cut the beams to put a 1-inch thick plate so that the beams would not go any further, and it punched the plates through the abutment again. That's how much movement we're getting. So we had to come up with a design with CFA piles to anchor the bridge. That main beam here was designed by my classmate. I wouldn't call his whole name, but Danny Chin. In that we had two 500-ton jacks that we jacked each system against each other to get movement. And then we cast the beam to transfer all that load to the piles. That's the difference in when you understand the slope stability analysis of how deep-seated the movement was. And for engineers who design embankments and bridges, just for clarity, when you want to approach embankment onto a bridge abutment, you have to consider that there are additional stresses on the piles. The embankment produces additional lateral loads on the piles, not just the active that you measure from your Ka, PA equal half Ka 8 squared, right? Gamma. So you have to consider all of those things. The other thing the engineer did not consider is that the wing walls were tied to the main abutment and they were not piled. So all the lateral loads on the wing walls were actually transferred to the abutment and transferred to the piles, and the load was too much. It just shear off all the driven piles that were there. And that's how deep we had to go to stabilize this thing. You know, Dr. Gay, as brilliant as he is, the shape of the design is for a reason that the resultant load, right, is at an angle. So he wanted the piles to be designed on a downslope so that if the bridge tries to move, it pushes the piles in the ground and increases the actual capacity. That's the solution implemented. That's the guys taking out the jacks. Right, and we move on now to reinforced earth slopes. These are becoming very common. This is one we did many years ago. Very neat. As you can see, these designs are predicated on, less thickness at the bottom where the stresses are higher, and we increase thickness as you come up. This was done with the Armtech 855 geotech style, no concrete. So, in true with our sustainability plans, we try to do a lot of projects that we reduce the amount of trucks and concrete and emissions coming to site. And that's what Tensar allows us to do. And more our clients are asking for more sustainable designs. We have reinforced earth slopes with these coconut fibers where you can put topsoil, put the coconut fiber and stabilize the slope. And then you could spray it and vegetation grows for erosion control. We have no cut slopes. We have to understand, when we cut a slope for it to remain stable, how we do it, is it going to be stable? Have you considered what we call pore pressure changes in the slope when you have rapid drawdown? In other words, when the reservoir goes down, when it's refilled, how does the pore pressure regime inside the cut, how do you model it for long-term stability? Embankments. With a lot of highways in Jamaica, embankments do fail, especially on soft soils. Imagine you put down all this fill to build your highway, and you come back the next morning and half of it got moving. In this case, the organics on this side is about 25 meters deep. It required construction at a rate of about 300 mils per lift every 5 days. But sometimes you answer to the political directorate where they want the highway open fast. For this job, they had to do this about 3 times in 3 different sections to the point where they just remove the fill and use lightweight foam because the soils were just too soft. Right? So you have to understand your geotechnical conditions before you can design these things, or else you'll feel the consequences. Right? Pavements. We do a lot of pavement investigation and redesign. And as you can see, rutting is a big thing. You have to understand the stresses below into the subgrade and sometimes what material is used in the design. In this particular case, as the government expanded the highway, sometimes they just widen a shoulder. Sometimes the shoulder is not designed to carry. Remember, as you move the traffic to the left, the heavier vehicles move as well. So if the trucks coming from the quarries are coming in now to drive on the old shoulder that is just expanded or widened, sometimes it doesn't carry the load, right? So you have to investigate the pavement to understand what do you want it to do and how long do you want it to remain. Right. Hold it on time, Victoria. So site investigation is critical to preventing all that we just saw a while ago. Right? And it's important that we get the information so that we can actually do it. One of the major complaints that I hear every time I come to Jamaica, man, them take too long, brother. 1 year, 6 months. Those things are unacceptable in this time and day. Right? Jamel said that, I eat cascadura, but unfortunately for me, when I came home, there was no work in Jamaica at the time. So I had to go back to Trinidad, who was booming at the time, and work was just flowing, right? When you have a student loan at 21% interest rate, you don't have a choice, right? So I stayed, I learned, and here I am today, able to stand before you to do my part to help my country, right? So the investigation is very important. It is for any site development project, we have to carry out this process. I'm going to explain to you why these little things are important. Engineers, observation is critical, right? When you're on campus, Hermes could see girls from miles away. Observation. So it's for your job, you have to understand what are the things that will have an impact on my project that I need to take into consideration. This document I'm going to share is from the oil and gas sector, and it outlines the entire specifications for site investigation, right? All the ASTM standards, what you need, so that you guys could understand what is required you want from the geotechnical consultant. 5 minutes, right? So for this document also, they have a checklist. It goes through every single geotechnical response that you want, right? And you can just tick off the things in Adobe and send it to the consultant exactly what you want to be outlined in the report. It covers every aspect of the geotechnical practice, right? For this study, we need the maps because we look at things in terms of scale, right? For a house, we wanted the 2 boreholes, right? But for engine, sometimes we send the surveyor out and the man only survey within the boundary. But look next door. We have things outside the cadastral boundary that are going to affect the project. So sometimes you have to look outside the site to ensure that you cover everything, right? So for this particular project, the client surveyed just beyond its boundary. That's the extent of the site, the mountain behind the property. So the catchment and the size of the catchment. That water course came down. He wanted to build a townhouse. And luckily for him, he cut the slope. And during construction, that's a day when nobody was there. The mountain came down and took half of the building and crushed it. It would have killed everybody inside there. Right? So this is to show you why the maps are important, why we need to study things outside the site boundary because they can impact your site. Right? This project is a housing development. And we're looking at these 2 buildings right here. 40 meters long, 4-story government housing. We have a river that's meandering outside the site. Nobody considered the implications of the river. Where is the exit, fire exit? It's 7 feet above the ground. So that's where the ground was. The entire slope failed into the river after a heavy shower. And you could actually walk and see the piles and foundations under the building. These buildings had to be demolished. You can see Dr. Gary standing up right there. Right? How we're going to solve a problem like this. Site reconnaissance. I'm going to stop after this because there's so much more I can say. I'll show you this last example. For the students over there, engineers need to go on site. This thing we're going to sit down in office all the time and run computer. I cannot design anything I don't see. So you need to relate the two by going on site, going in the bush, spread a bush, put on the coveralls and things, and observe the site, right? And it gives a good indication by talking to people what you can do. On this particular site, we went using the maps and looked at what took place. It was a quarry there years ago. When I went on the site, I saw some guys. There are some squatting communities around the site. Some say, yo, dada, what go on here? So how come nobody no squat inside this stuff? Man said, boy, daddy, bossy. Every time rainfall up moving. Not one borehole had to be done for you to get information. Obviously, you'll have to verify it. Government didn't listen. They went ahead and they put the building. You see that red line there? That's a scarp. When the guys cut the quarry in the mountain, they pushed the spoils down slope. Over the years, grass grew up, looking nice, look a nice slope inside. Let's go build government housing. 52 million, 1 billion in Jamaican dollars today. Failure. Right? So going on the site, understanding the requirements, the history of the site, but it's a greenfield site, a site that was developed before, right? They tried all kind of things to save this, they had to demolish them. Right? And there's about 200,000 people on a waiting list for housing. So the lessons learned that I just explained, right? That the death study and the site reconnaissance should be used to plan field investigation from the boreholes, going on site, seeing what you have to do, cut access if you need to see all aspects of the site. These things I could share with you in terms of planning a site investigation. For a tank, you definitely want the one in the center, one at the edge, for differential settlement. For a building, there are many guidelines of how we can do. Simple things like a test pit. And you need a staff properly so you can see the pictures properly, right? How things transform and change. You can use an excavator just to document what you see. Standard penetration test, which is really what we do. This is one of our latest rigs that we have. We have just upgraded it to do also CPT, right? And Herbert would understand this, but you can't be a grub and use this rig. You need at least 3 brain cells, right? Guys have to be trained. Okay, you can lose a hand, lose a finger if you don't know what you're doing, right? So our technicians are actually guys who use this type of rig, right? I'm gonna skip that. That job we did in St. Lucia. The CPT now is what we need for soft alluvial soils because everything is computerized and it's giving you data real time. You can stop the cone. If it's a piece of cone, you could actually measure pore pressures in the ground instantly. You could do a consolidation test in the ground. The only thing is that these things are not cheap. The probe alone probably costs about 8,000 US, right? But it's needed to give you the information in a faster time frame and also needed for liquefaction development. So this is a typical cone resistance output, and you can actually get shear wave velocity directly from the cone, right? You can also use a metal plate at the surface because you have the wires going down, and you could strike the plate, and you actually get a response in the ground and actually measure the shear wave velocity and see how the soil responds to that wave. And this technology is not new, right? And these are some of the things that we do. These are the outputs from SPT against shear wave velocity to kind of determine the side class, right? Right? So we do all these lab testing just to get the geotechnical parameters. These parameters are plugged into models like these where we can actually model an embankment, the slope stability, the full gambit of the design and actually model it according to the construction output, right? For most of our sites, I'm going to do my own graph, probably present at the JIE one day, in that the monies that clients have lost in terms of the cost comparison for a site investigation is chump change, right? Here's one site, the client said he only wanted 2 boreholes. We did 2. This one was completely different from the next. One was soft, one was hard. Which one do you use? The soft? Well, he implemented one pile. He got 60 tons on gravel at 3 meters. The next pile disappeared in the ground. He spent 1.8 million TT dollars. That's over 30 million Jamaican dollars. When he could have spent less than a million Jamaican to save the problem. And I could go on and on and on and on. In that somehow we have to educate the clients to understand why the investigation is critical. Everything starts from the ground. And we need that parameter thing. So it's not something while it can be rushed. So my advice to the fraternity is that we're going to take our time to build capacity. We have the talent in Jamaica, right? We have the regional presence that we can cross collaborate, right? And we can build the capacity. I work at Gentech in 1998 as a summer student. And when I go down there, I said, well, what's going on here? You know, we're supposed to be doing the things, you know. I work in Jamaica up in Clarendon from another summer job. But when it's time for real work, that wasn't available. So I would like to share my expertise in building capacity for young engineers, the geotechnical practice. We need talent. We need people who can sit down, stay focused to get this right. Because once this fails, everything else doesn't matter. You have to get this right. There's no second guessing that. So folks, I thank you.
Wow, very interesting presentation, Mr. Allen. Thank you for that. So we're gonna have a slight change in the agenda. As you all may have been aware, we would have had our second speaker now, but instead we're going to take a break. So you guys can make your way over to the buffet and then we'll continue after. to invite our next presenter while we're eating. So next we will have Luis Velez. Luis Velez is a regional manager at Tensar, a division of CMC, and has over 30 years of experience in the design and construction of civil structures using geosynthetics and other construction techniques. Before joining Tensar's design team in Atlanta, Luis was part of the design and construction team in a firm in the Caribbean, specializing in geotechnical structures, landfill expansions, and soil anchoring systems. After several years in Tensar's engineering department, Luis became director of operations for mechanically stabilized soil walls division, managing the United States, Western Europe, and the Middle East. His passion for effectively teaching others about concepts relating to geosynthetics and their applications in civil engineering motivated him to move to the Latin American market, where he now performs complex, commercial, and technical supporting roles. His primary role is to train non-industry colleagues on complex geotechnical topics in an easy to understand manner. For the past 5 years, Luis has been part of a select group of Tensar engineers mentored by Andrew Lees, founder of GeoFem, in disciplines of numerical analysis and finite element modeling. This program has been a challenge and has pushed Luis out of his comfort zone in terms of complex knowledge of soil mechanics and geotechnical aspects. Ladies and gentlemen, please join me in inviting Luis Velez to the stage.
All right. Thank you very much. Enjoy the breakfast. All right. So first, we would like that you guys take your time and maybe use the QR code so you can get a certificate of the participation of the event, and that will be emailed to you directly. And make sure that you put the right name. If you cannot do it that now, don't worry. At the end of the presentation, we will do that again. Okay? Okay. And by the way, the when you go to the oops, sorry, there you go. When you go to the app, they basically will ask you your name. Make sure that you put the name exactly the way that you want to be printed on your certificate, and then it will ask you to select which event or which training section you were involved today. So that will be section 110, design and consulting with MSc engineering solution. All right. Okay. Everybody's sticking. Perfect. All right. Also, if you, for any reason you have any issue with the app, you can send us an email to latan@cmc.com, and we will also respond through that email to get your certificate by the completion of the event. Mm. Don't worry. At the end of the section, we're gonna have that posted again. Well, so I guess we should start uh, back where Charles finished. All right. Then basically all that geotech information that he gathered on the project, that's what we're gonna use in Tensar, working with your guys to develop a solution to be cost efficient and safe for your projects. Um, Something very important of what Charles said is that that money spent on the geotech report and the investigation is that it's not a cost for the project. It is actually a saving for the project because by the time that you get the contractor at the job site, if you haven't figured out your foundation yet or your information is sketchy, you will pay for it. You will pay for it. And you will pay by money or you're going to pay with your reputation. Okay? So it is very, very important and it's a money well spent. Okay? Using that information is what we're going to do to take advantage. In Tensar, we have many, many engineering solutions, but with that geotech information is what we're going to help you to develop a system that will be feasible for your project. First, we're going to talk about retaining walls. It's my passion. It's what I spent most of my career in Tensar. And let's going to start very simple, all right? So a retaining wall. Retaining wall is very simple. Is we're just going to take the aggregates and we're going to create change of elevation in our project to make the changes that we need. Okay. So take a look to this structure. It's a very simple structure that will acting like a retaining wall. And the marbles that we have on the back, it's kind of the soil. All right. So you can see that after we reach some elevation, 8 centimeters, the structure fell. All right. So now we're going to take the same structure and we're going to switch that. We're going to put the same marbles. And now we can get a little higher. We can get up to 11 centimeters. It's the same structure, the same marbles. We use them in our advantage. Okay? So we use the soil as help to make our structure stable. So it's very, very important that my friend Charles understand that soil because that information is what going to give you and me the parameters in order to extract as much performance from that soil that you already have at the job site and you already have to spend the money on it. Okay? So now let's gonna try to do something with that soil and that information. I'm gonna use one of my colleagues here, Angel Conde, my boss here, and we're gonna use him as my model for this demonstration. So I'm gonna ask him to miraculously make a cut and holding that backfill instantaneously. Okay, so there will be no deformation. That is called at rest. So there's no deformation on the soil, and he's doing all the force to holding that in place. My boss haven't been in the gym lately, so he get a little tired and he allow a little bit of deformation. Now my soil condition is on the active state. And if you can see, he's not holding the whole soil. He's only holding a wedge, a part of it. And that's how the geotechnical engineers, we lie to the soil and we making them work for us. You can see on this demonstration that that retaining wall that I'm moving forward basically create a wedge on the sand. Also, so depending on what type of soil I have behind, I have to put more force or less force. If I'm working with gravels and sand, easy. If I'm working with clays and silt, more challenging. All right, so now I don't need my bus anymore, so let's get out here. All right, perfect. So we know that we need a structure over there. What kind of structure? We haven't decided that yet, okay? So if we understand the soil, and if we understand how much force that soil will apply to our structure, now we can make a choice of what type of structure to use. Let's say we can use a casting plate, concrete wall. We can use a gabion wall too. It's a gravity wall also. Or if you want me to pay all the bills, you can use one of mine. All right. At the end of the day, both structure, the concrete wall and the MSC wall, are very, very similar. So you guys, I'm sure that you guys on your preparation did some kind of calculations to design a concrete wall. It's not much different than a MSC wall. Take a look at this. And this is like just a demonstration how when we incorporate a foreign element or geosynthetic inside of the soil, we can change the behavior. The first sand castor doesn't have any geosynthetic. The other one has some tissues, and you can see how much loading they can hold it now. This is a very good beer trip. If you're in the beach, you want to get a beer, you bet that with somebody, and you know the trick. So, or with your kids, you can do that with your kids, and they will be amazed how dad can do that. All right, so for this type of structure, we have to check as any gravity wall. We have to check the sliding. We have to check the overturning, bearing capacity, and all those freaking stuff. All right. But at the end of the day, the structure is just as simple as a reinforced mass with a retaining soil and a foundation soil to support it. The facing can be whatever. Charles show you guys different retaining walls and slope with different facings, so we can accommodate whatever facing is needed. Sometimes, depending on the facing, we're gonna need a level impact just to make sure that the first row of panels or blocks are level. Geogrid, that's what's gonna confine the soil and create the mass. If you see there, if I adding 300 more layers of geogrid there, it's not going to change the behavior of the block. So when you hear somebody say, hey, if I using this type of geogrid, the length of the geogrid can be shorter. That's not true. At the end of the day, the soil weight, whatever is weight, and the mass is whatever is width. Okay? Very important, like any retaining wall, it's very important to include your drainage system. If not, you're going to pay the price. Just spend pennies on the drainage system will save you thousands of millions of dollars or your reputation. Right? So now that we understand what a gravity wall can do, we can make a choice of what type of retaining wall to use. And we have many options that we can work with. One of them, let me move. There you go. One of them would be precast panels. You can see it could be a beautiful or as plain that could be. Very easy system. Have a mechanical connection behind the panel. It's very easy to install. It should take only 30 seconds per connection, no more than that. So this is my friend. This is in Macon, Georgia. I went to the project, show him how to do it. Then I told him, hey, now it's your turn. Show me how to do it. He just got it. Very simple. 100% synthetic. So that means that open the possibilities of what kind of backfill can I use behind. Another type of block of MSC walls would be what we call mesa. I'm sorry, I'm trying to get my cursor here. There you go. On that one would be cemented blocks. Again, mechanical connection. What is mechanical connection? Very important here in Jamaica because you have a very seismic active zone. Okay, and that mechanical connection between the facing and the reinforced mass is very important. So again, you can reach whatever height you want to, and if we're doing the design correctly. Okay, so we can have a landscaping wall or this wall like a 60 meters high. Next, I have something that is called Sierrascape. It's a wire basket, mechanically connected also. And you can build the retaining walls at whatever size you want to with the facing or the aesthetic that you may interesting too. You can vegetate those too, if that's your choice. Sierra is our slow system, and they can do vegetative phase or rock phase. You can have a wire basket at the phase or just plain. Take a look at this one. This was built in China, the reinforced slope, and then after 1 year, it's completely covered and nobody knows that it's there. This is the Walmart in USA. You can see that it's also covered. This is with the Disney Park. That's one of our key accounts, and you can see residential projects with vegetative phase. Jamaica is a beautiful place, and we definitely may not want to put too much concrete everywhere because one of the beauties of the country is our vegetation. So definitely is an option. All right. So with all those systems, they are basically, oops, sorry. With all this system, we can now incorporate that in your project. Let's say that you have a concrete wall with a slope on top. Well, we can switch that to a MSC wall with a slope on top. Okay, slope on top of any wall is a tricky part. Okay, it's not a simple design as supposed to be. So we can have a reinforced slope on top and reduce the height of the wall, or we can switch, and this is a more stable condition for the calculations. Okay? Or you can ask for what my kids think that should be the right solution for every project that is a vegetative phasing. Depend on the type of the phasing, the cost associated with them, so it will be different too. If we go through the vegetative phases, it will be less expensive. If we go with panels, it will go a little pricey, right? Let me pass all of this. Okay, so in order to design this, you first need to have the geotech information. You need to fully understand the technology and the concept behind the design. So that's where Charles and I will be here. I'm more than happy to come back to Jamaica and explain you guys step by step how to do the design. So that will be a very excuse for me to run away from the cold weather in Atlanta. So please, the cold weather are the best for me to come. So this is our software. It's called Tensar Soil. I will tell you guys at the end of the presentation how to get copy of them. But you can see here is very simple, easy to use. Um, I could select just what type of project I want to design and select the facing that I want. That's what I'm doing here. Once I select the facing, I could select what design methodology I want to use. That's very important to understand the pros and cons of each one of them. I could apply my loading conditions or my seismic ground acceleration. Change the wall height, the soil types, everything in just one single software. And I could design and analyze any project on it. Okay. Okie dokie. So now that we have understanding of the retaining walls, let's gonna look for slope. Okay, slope is another type of structure. It's a gravity structure, but um, we analyze that in a different way. When you're trying to apply the retaining wall calculation to a slope or where the facing is too flat, uh, they don't work quite right. Okay, so the calculation doesn't work out quite right. So for that, we on the slope we're trying to use equilibrium element design that is basically make sure that the acting forces and the resistant forces are on check. Just to give you an idea, a slope, very flat slope with a well compacted material will be pretty much stable by itself. But sometimes when we try to push the limit, then we need extra help. Okay, let me show you this sample. This is the slope, a 3-to-1 slope. And you can see that by itself, the soil on this case is completely stable. Factor of safety of 2. Perfect. It's going to push the limit a little bit. Now this is a 2-to-1 slope, 26 degree, and you can see that the factor of safety is 1.4. Depending on the structure or the use of the slope, it could be okay, or we need to do something else. Let's say if this is a road, probably will be fine. If we have a building on top, a hospital or something like that, no, we need to increase that factor of safety to at least 1.5. Take a look, the same soil, the same height, we push now to 1.5 to 1 vertical. Now the factor of safety is on the compromise area. And if we go 1-to-1, then our factor of safety is below 1. That means that I have the potential, high potential of failure. Okay, so we can incorporate the geogrid or the geosynthetics that we mentioned before. And the type of geogrid that we're going to use for that kind of application would be something like this. All right, this type of geogrid basically transfer the loading in just one direction. That's what I'm looking for in this type of application. I want to add force to my slope so it could be stable. So, oops. So you can see here the factor of safety of all of them. And when I reinforce, when I apply seismic conditions, the factor of safety, even the one that is reinforced, doesn't meet the requirements. So for that reason, I had to increase the length of the geogrid in order to be able to achieve the factor of safety. When you're doing your analysis for cost-wise, then you have to look everything on that analysis. Basically, if you have a 3-to-1 slope or 2-to-1, you have to take in consideration how much land you have to, or the saving of the right way, the cost of the geogrid. All that analysis will be part of your cost analysis just to make sure that you select the right solution. Again, depending on the system, it will be how much will be the cost for your project. You can reduce the right of way. You can increase your flat area of your top of your project. You can eliminate a retaining wall, or maybe use that for a slow repair. All right. So Charles showed us very nice pictures and projects with problems. But let's going to take a look to this in more detail. We have our soil. That's what compose our slope. And if we put a house, the beautiful house that we want, that everybody spend a lot of money on the architect, structural engineer, and everybody else to design that house, but nobody spend money on the geotech report. So now we have the house with a beautiful view on the on the top of the mountain, but that loading, the soil doesn't like it. So portion of the soil trying to holding the whole thing together, but the other portion of the soil trying to move in the opposite direction. So what is happening if I'm looking in details here, and this is one of the tests that Charles is going to do, is basically he's going to take that soil and he's going to try to make it that shear so he can understand how much force he can extract from that soil. So I push it from one side, holding from the other side, and now I understand how that soil will behave in a failure. If I look at that in detail, every grain that is on the soil would try to help you until the level of the load is too much. So this is what's going to happen to the soil. I apply the loading, and they're going to try to move, right? So that's how Charles would tell me, Luis, this soil have a friction angle of whatever, and have a cohesion of whatever. Those are the parameters so we can design the slope. All right. And he's going to perform maybe direct shear test or triage test, depending on the type of soil and the conditions that we look in. All right. So we know that if we have a loose soil, you can see that every aggregate have a very tiny connection with the next aggregate. If we, that means that that's how the force would be passing from one grain of soil to the next one, to the next one, right? So very important equation is to understand here that if we have that material not well compacted, then it will have a lot of deformation and it will be easy to find a failure plane. If we adding water to that, rain, time that I check, it rain here a lot too, then now I have some kind of lubrication between the soils, plus the water would try to push the grain apart. That's the pore pressure. That's something that Charles will measure on his testing also. He mentioned few failure planes or failure cases where the pore pressure was the main reason of the failure. That's what is happening when you're looking in very, very detail. Okay? All right. So one of the solutions would be to compact that, to have a better compaction. So you can see if I have a better compaction, how you can achieve a better compaction without testing on the field. Just by feeling, that's another thing. So during the construction, we need to make sure that we do a quality insurance during the construction to make sure that we achieve what we're trying to design. So if we have a better compaction, you can see that now I have a lot of particles in contact to each other. So I have the same soil. It is the same soil, but now behave different. So when the soil is not enough, then we add an extra force on that. That is to a geogrid, like the one that I mentioned to you, to compensate for that force that we need. Okay, it's more complex than that, but I want to keep it that simple for now. Depend on the failure, we have to look what will be the solutions also. Okay, typically the type of failure that I have been researched here in Jamaica have been these two types that will be the transitional and rotational, and those are very highly influenced by water levels. So very important. There's always signs on the project that you can just by go there, you can start to explore if there was a problem with the stability on your project. Okay, so if you see trees that are not lined up, fences that are not perfectly plumbed, those are signs that give you the soil, the project, to tell you that, hey, look at this in detail. You don't want to be on the news. All right. All right. So with that, I basically cover what would be retaining walls and slope. Very important. I feel so odd here. I like to move. Okay, so very important. Geotech report, very important. That's what gonna give me the soil parameters so we can design the structure. If you don't have the geotech report and you design a retaining wall with just a standard copy paste detail, it's not that you're lucky. is that you are pushing your luck, and it's not it's not if it's gonna happen. It's gonna happen, bad something bad to you. All right, it's just a matter of time when it's gonna happen to you. So if you want to push the limit and get it done, you know that you're gonna pay with money or your reputation, right? Most of us, like me, including, we don't have that much money, but our reputation and our um, career is the only thing that put food on the table. So um, it's not a spend. It is just a well invest money so you can sleep like a baby every night. Okay? Let's gonna change the the topic now. So we're gonna pass from retaining walls and slope. That is awesome, beautiful, and that's the best part of my job. Now we're gonna pass to foundations. And you guys have here doing my research for this event. I didn't know how much trouble you guys have here. Okay. So let's gonna start with liquefaction. Liquefaction in the geotech community is still a topic that is still like a baby. It's only like a 50, maybe 55 years that we are, as a geotechnical engineer, looking into. So that means that we don't know much. And the little that we know, as a good geotechnical engineer, we argue with each other. Okay? So that's very important to argue a lot. I'm just going to explain you first what it would be the solution that we bring to the table, and then I'm going to discuss the details behind that. Okay, so this is your beautiful house that you want to build, and you bought this very cheap land somewhere close to the airport. That is not that cheap over there. That's what I was told. Um, and you just want to build your dream house over there or your dream project. All right. And then you contact Charles, and Charles came to do the soil investigation, and he bring bad news. He tell you that the soil have the potential to liquefaction. That's not good news. You know why? Because it's gonna take more time, and it's gonna cost you more money, regardless. Or you can just stick your head in the sand like a hamster and wish for the best. Okay. So this is the solution. We're gonna remove part of that soil, the upper layers. We're gonna extend a little bit outside of your structure. We're gonna stabilize the section with a product, something maybe like this. Okay, that will create like a rubber wrap, stabilized rubber wrap, and that will be the solution. Okay, let's gonna let's gonna look into the details of that. So as I said, liquefaction is something, it's not new. It's always happened since the Earth has been created. We only have paid attention to that in the last 55 years. And we have all have seen these pictures around the world of blah, 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 the liquefaction effect and that kind of thing. And those are textbook pictures, all right? As recently as 2024, this happened just right before I was doing a presentation in another country. So, but look at this picture here. It's from 1692, and it was artist that drew this for UK newspaper, where he showed or expressed that there are some liquefaction issues over there. I'm sure they didn't know that that was a liquefaction, but you can see on the picture that it is here in Jamaica, and it's an expression that something happened to our buildings. If you're looking in detail your map, first the ground accelerations are very high, and they have many areas in many reports that are already telling you that this event have been being experienced here in Jamaica, and one of the first uh, uh, data that Charles is gonna look, it will be if this happened before in this place, because that's one of the check mark. If this happened before, guess what? It could happen again, right? So this is liquefaction. So it's very fancy word, but at the end of the day, it's just this. We don't fully understand that yet, but this is what it is. Imagine that you have this box that is the soil, and you can see that the soil is surrounded by water. And you can see that the spacing between the particles is the maximum spacing possible before the particles stop touching each other. Okay? So now I need a little bit of your imagination with me here. We're going to apply a shear force, and that shear force could be an earthquake, could be, let's say, a manufacturing plant with a shaker, or a mining with a shaker. It could be something that hurts some vibration on your soil. So when that happens, now I need to do like a matrix and stop the time. So there's two options here. The first option is that you can see that now the particle doesn't touch to each other, but if we allow the soil to drain very quickly, has to be very quickly. Keep in mind, this is events that happen in 30 seconds, 15 seconds, something like that. If I allow the drain and the soil to drain, this is what's going to happen. The soil will set, and just depending on how deep that happens, your structure on the top will suffer or not. Okay. Now I need to go back on time, like a back to the future. You know, we're gonna go back, and we're gonna do the same stuff to the soil, but we're gonna stop the drain. I'm not gonna let the soil to drain. And look up, and you can see that the particles, they don't have place to go. The pore pressure will increase substantially. Now the soil will behave like a liquid, and that's liquefaction. Okay. When that happens, you will see sand explode through the side of the upper portion of your site. You will see sediments, differential sediments, and you will see this effect that is called rattling on your foundations. Okay. All right. So the current practice is have been very simple around the world. They they know that if I remove a little bit and I replace that with a well compacted material, everything's good. Well, that is good enough. But when the client asks you, okay, so how much deformation I'm gonna have eventually? I don't know. How much force or factor of safety have my structure against this event? I don't know. I know that this just work. That used to be the current practice. All right. And so it's basically we know that it work. We just cross the finger and hope it for the best. And there are hundreds and hundreds and hundreds of projects around the world built that way. All right. So let's gonna talk a little bit about the cross on top of the liquefaction soil or liquefiable soil. Okay, so first you need to understand that when Charles said to you that this, the there will be a change on volume of the soil of 3, 2, or 5%. It doesn't matter if you have a building on top or not. We are not there yet. We don't know. We don't know. So all this calculation is called what is a free field method. That is, if we have that change on volume on the soil, the deformation on the top could be on the order of 2 or 3, 5, 6%, whatever, but we cannot take in consideration the structure. That's how it used to be. And we have been dealing with this for 55 years. So. But it came Ishida, this guy, in 1985, and he took a trip and he plugged this. What about if I know what is the thickness of the liquefiable soil and I plug that against the crust that was on top that was competent? And you can see here I have this graph. And if I put a line, the red dots are where the liquefaction happened, or you can see it, and the green buttons are where they didn't happen. So simple. We just have to be on the side that would have the smiley face. He also noticed that on every project that he looked at, that he didn't happen the liquefaction effect. The factor of safety for the bearing capacity post liquefaction was 1.5. He saw that the sediments were less and that the structure performed. So that was good enough. Then Brian Macedo came in 2017. Just happened. Just happened. The paper is Brian Macedo. There's a lady, Graciela, a PhD student from the Colorado University. She was a big, big influence on this paper, but for some reason they didn't include her. But that lady was basically who did all the parametric study. So what they did, they took every equus from Ishira plus every equus that had been happened that with liquefaction, and they plug that in a graph that give you what is the factor of safety of bearing capacity after liquefaction and what was the sediment reported on those structures. And this is the graph. That is perfect for us as an engineer. So we know that if we design for factor of safety of 1.5 or more, or 2 or 3, the sediment that our structure will suffer can be determined. Okay? So now we just need to do the calculation of a 2-layer or 2-system soil to determine what would be the bearing capacity. You can see here, I just need to make sure that I have 1.5 or higher factor of safety. I just need to determine what will be the thickness of that gravel raft. For that, Andrew Lee, Dr. Andrew Lee, he did this method that is called the t-value, and it's basically a calculation to determine the bearing capacity of a 2-layer soil. It sounds simple, but if you go back to your school book, you will see that every sample is with just one soil, and when you have two, you are forced to use Meyerhof and hand that basically has some very strict condition that the angle of dissipation is X or whatever, blah blah blah, and it's not it doesn't reflect well the reality. Okay, can put applied load, and for that he went to this paper. Okay, so with that paper, he basically what he did, he took all the testing and he plugged that on this graph. What is the H, a relationship between H and B of the foundation, and the bearing capacity of the subgrade and the bearing capacity of the aggregate, or the applied pressure of the aggregate. With that, he created this equation, very simple equation. It's basically the relationship of the bearing capacities and plot equal to 1 plus t, that is basically the slope of that graph, and multiplied by HB, that is X, right? Let me go back. All right. So for that, he did a parametric study, and he get the T value, or the letter T. T means the efficiency of transfer loading for aggregates. And you can see that the green line is for just aggregate, and the red line is when we use one on this. Okay, let me go back. Let me go back here. Okay, so once again, the t-value of the equation for spread footing, and we have a different equation for circular and square footing. Okay, so this is what Dr. Lee did. He took many, many research around the world, and he plugged those to find out what would be the efficiency of the aggregate. This is multiple testing around the world, different researchers, and this number that is here is the friction angle of the soil that they were using. So let's gonna pay attention to 40-degree angle. This is the line. You can see all the researchers lined up very well. That gave you a lot of confidence on the design method. If we if we're looking for square and circular, the data is scattered. It's not as simple as that. So for that, what we did, what he did, not me, but what he did is to choose the lower bound of the data in order to make it to be on the safe side. So now I know that if I incorporate this on the aggregate, the behavior of the aggregate is different. Doesn't have anything to do with the resistance of this, the torsion rigidity of this, and all that marketing crap that the industry have. Okay, you have to do the research to find out what will be the t value of each product for each aggregate on the different conditions. All right, so now I know that this change the behavior. Um, ISO, IGS, all of them have recognized the stabilization as the improvement of the mechanical behavior of the soil. They change the behavior by reducing the deformation and the particle move. Okay, take a look. This will be very cool. So this is a research from Penn State. They create the smart rock, and let me go straight to the testing. Okay, so this is the smart rock. You can see that in real time, I could see the rotation and the translation of those particles. So if I put it that in a test with and without the stabilization, you can see that the behavior of the soil is completely different. So on the first one, you can see that you apply the load, it move, it can back a little bit, but the deformation is cumulative. On the one that have a mechanical stabilized layer, you can see that the deformation is not that much. The same aggregate, the same loading, the same cycle of load, but different behavior. You can see here the graph that show the translation, but the more important one is the reduce the rotation of the particles. You guys have here a limestone, and that's very, very important to restrain the movement on them, because if they scratch each other, they will be breaking. Okay, so this is the typical aggregate, how it behaves. When I lock it that in, now the aggregate behave different. It could hold in more load and restrict deformation. So all the geogrids work. Different type of geogrid I have here, all of them work, but they work different. And I cannot make a design with one and just select the product data sheet and say that the product data sheet of this one is equivalent to this. You have to do the design of each one of them. So this is the lateral confinement that is achieved with this type of technology. Okay, so now that I have them, I could go and create a parametric study, determine what is the t value, do a full testing, apply what Ishida and Macedo create, and now I have a system to deal with liquefaction. At the end of the presentation, I'm going to show you guys a sample how to do the calculations. So So not just for liquefaction, I could do that on regular bearing capacity. I could increase the bearing capacity of your soil. Let's, let's forget about the earthquake now. But if I do this type of technology, I could increase the bearing capacity between 1.5 and 3. I could reduce the sediment between 40 and 60%, and basically reduce to eliminate differential sediment. So that's another application. Typically, we do building between 1 and 5 stories. We do um, retaining walls on top of this, or catch basin. That's another option for this type of applications. So whenever you have a problem with your bearing capacity, that will be one additional tool on your toolbox to deal with. All right, so we finished with the foundation. We finished with the foundation. Angel, uh, I told him that I'm not gonna allow him to talk, so I'm gonna do his presentation. All right, so for that, okay. All right, so let's do. Let's gonna change the gear now. So we already saw retaining walls. We saw foundations. Now let's take a look to roads and highways. For that, prepare this very quickly here. What do you think if we go out there and we ask the Jamaicans what they think about the country roads? What do you think would be the opinion? All right. The the only problem with this perception of the public is that at the end of the day, guess who they blame for? To to us, the engineers, the contractors, the consultants. That's what's that? What that's where they put the blame. All right. They can blame politicians also. I don't know. But at the end of the day, is that the people who are in this room, civil engineers, contractor, we we sometimes overlook, or we let the pressure on us to do the wrong design. Okay? And the problem with this is that if we keep doing that, we're insane, because don't expect different results, don't expect different roads if we keep doing the same. Okay? So So how we can go from a conventional traditional design to something different? All right. And here in other parts of the world, we use ASHTO 93 for the design of ropes. And how I'm gonna incorporate this in that design is kind of tricky. Okay. So let's gonna take first the conventional design, the ones that you do every day. On that one, basically you take all the parameters for the calculations, and then you create a structural number for your payment section based on what is the contribution from the asphalt, what is the contribution from the base aggregate and the subgrade, and all that you adding all that together, and you came back with a structural number that reflect what is the structural capacity of that section that you just imagine. Okay, perfect. So let's say that for this sample that we have 4 inches and 10 inches of base, that gives me 176 easels. That is basically how much damage from trucks I could get. All right. So my question to you is that um, where, where in that equation I put this? There's no place there. So we know that the traffic get better when we include one of these technology. All right. And if you follow the marketing, and if you go to internet, basically they're going to talk a lot about TBR. TBR is the traffic benefit ratio to include one of this. And they typically give you a number. Or most likely you will find graph show what is the tensor strength, the rigidity test, the torsional test, and they will tell you the higher numbers that you can hear or whatever. At the end of the day, none of that data means anything for the payment design. Take a look at this graph. This is the TBR, is how much better the road gets if I incorporate one of these technology. And you can see that I plug that against the tensor strength of one of those materials. The tensor strength of the material doesn't correlate with the benefit on the traffic. So when somebody, including me, came to your office with a literature with the properties of the material, as soon as I left that door, you take that piece of paper and you put it on the trash can. Okay? Don't do it in front of me, so don't hurt my feelings. Okay? Okay. So Ashto recognized that, hey, this work. So basically, they create this document R50-09 that basically say this work, this reduce thickness, this improve the payment life, but you have to test the session. You cannot use the physical properties of the material in the design. You have to test the 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 section. Okay. So what we did as an industry, we get very creative. So everybody started to do their own tests, and now you, as an engineer, you receive multiple tests, but you don't know which one is correlate to the other one. So that Ashton came with the idea to produce this report 512, and that tell you exactly how the testing has to be done, how many testing, etc., etc., etc. And this is have to be done in advance of your project. Okay. So after you do all the testing, you have to send that to a third party reviewer, and they will be the one who gonna assign what is the structural capability of your section. Keep in mind, they say that the properties of the material, the physical property, the properties of the material doesn't correlate um, with the performance. Okay, so this is how the testing is done with them. Then now that I understand what is the different behavior of my aggregate, and depend on the thickness, the strength of the subgrade, I could assign the new coefficient. So the coefficient is based on the aggregate quality, the subgrade. Now I could take the same row, redesign that with a new structural value and the material, and I get a different performance. Or I could use that in my advance to reduce the thickness of the section. All right. I don't want to finish without show you guys the Tensor Plus. This is the design tool that you guys can go and access right now. It's called tensorplus.com. Please feel free to download that, the app, and with that you can design all your payment sections. Okay. And last but not least, once again, this is the UI code for the certificate. All right.
All right. Thank you so much, Luis Velez. Very interesting presentation. And I'd just like to thank him again for taking the time. We were also to have another speaker, Angel. I just want to acknowledge him from Tensar as well. So thank you both for coming here and sharing this knowledge with us. I know we have done projects in-house that we've actually used the Tensar platform to do pavement design. So I can attest that it's very useful and very handy. So thank you so much for that. Our next speaker is Helber Gutierrez. And Helber is a civil engineer with 13 years of experience spanning geotechnical investigation, deep foundations, and marine infrastructure. He has worked in various roles, from field engineer to project manager, on piling and port development projects across Colombia, the Caribbean, and Canada. His experience includes work on major projects in port development involving driven piles, sheet piles, fender and bollard installation, and of course, barge-based construction. Elber's portfolio includes foundation systems such as CFA, DIP, driven steel piles and concrete piles, diaphragm walls, and soil improvement techniques. He will be presenting on deep foundation techniques available in the market and which ones are more applicable and most cost effective for the Caribbean. There will be a deep conversation on 3 piling techniques: continuous flight auger, DIP, ductile iron piles, and RFP, reinforced fiberglass piles. The presentation will include a comparison of all techniques, and then we can take questions and go into our panel discussion. So without further ado, Helber. Please just give us a few minutes while we switch over the laptops.
Thanks to all of you to stay here and to participate. And thanks for all that to just make this happen. I agreed on all that Luis and Charles said before. Sadly, in some communities, there not still a lot of understanding and they're underestimating the geotechnical part of the project, where the geo reports and the information we got from the soil, they're just another piece of file information that we are just putting next to the desk, and this is not actually looking into it. So the whole idea in here is to try to look forward to be more thorough into the knowledge of the geotechnical part and understand the piling that and the piling techniques that we have available right now on the market. To start, I just like to ask you how much or how many piling techniques do you have often used in here? There's any knowledge of piling happening apart from the driven piles that you have in the island? Not much. So okay, okay. So um, just before to go to the actual explanation of each of the techniques that we have selected for this moment, I would like to show you a list of some of the techniques that have been used in the world. With some of them that are not really applicable at the moment in the island. Most of the time is just because of the cost that it will incur. Most of the techniques that the piles it will have, it depends on the specialized equipment that, as you know, and it's been told already by Charles, it's costly to bring into the island, right? Everything has to be moved through barges, and some of the clients they can have better solutions with available equipment on the islands, that it'll have the same end result, right? So as you guys said, driven piles, that's one of we have. The only variation we have for the driven piles is the material that you're using to be driven into the ground. It could be timber piles, it could be steel pipe piles, it could be H beams, which I believe is some of the things that you use a lot in here in Jamaica. It could be fiberglass piles as well, and it could be precast, which most of the time they're precast concrete piles that they're driven. Um, Going into the other techniques, we have the auger piles. So auger piles, it can be split into two different divisions. We have the cast in place piles, that's the CIP it stands for, which mainly are used for big diameter piles, which they're correlated to a big load. So most of those ones are made for high-rise buildings, for big structures, or for any structure that require a high load capacity. Then we have the technique that you have been using here, and it's been used in most of the islands, the CFA piles, the continuous fly auger piles. That technique allow you to get to high capacities, right? But at the same time, the equipment that need to be used is not just related to a drill rig. And I'm going to show you later on how you can actually have a cost saving doing a CFA pile and not involved to bring a drill rig from a different country or just to purchase it. After those principal or basic techniques that we have been using into the islands and in the world, we have some other techniques that it will be applicable project depending. We have micro piles, we have jacking driven piles, we have the screw piles, and we already have something called full displacement piles. The last one sometimes is just mixed with a different technique, which is the ground improvement world. Today I'm not going to talk about the ground improvement, just to have a note in here. Ground improvement is another technique to be able to build a foundation. It's something available. The only reason why it's not brought up to attention to a lot of people is just because it's fairly new. Plus, the equipment that is going to be used is specialized. So you must get the equipment, which is either an investment or either a cost that is going to be associated to the project. It depends which way do you want to look at it. So before to start jumping into that, as Victoria actually introduced and said, I would like to mention that something that you guys, or at least the young engineers, are not looking at is the dream for an engineer is to try to get to the top. Everyone wants to get there, be a manager, be an owner, be a principal, a designer. But at least my perspective and my advice, what I just did myself, was to start from the bottom. When you start from the bottom, when you are on the field, when you check, when you revise, when you talk to your operator, when you talk to the frontman, when you share time with them, you actually learn. You actually have all the options and the tools that you need to right after couple years after jump into position. So I encourage the young engineers to go to that road. Sometimes it's the hard time. It's a hard one to follow, but it's really joyful. And the end goal that you get is just best just to jump into the ladders and try to get something else. So encourage you, it's hard. But I can guarantee the engineers who have more than 20 or more years experience, they will agree with me that that's the best way to go. Couple projects that I have done in the past, as Victoria mentioned, I have worked in Colombia, several projects, more than 4 major projects. Major, you could call it more than $50 million project each, when we have developed from ground improvement, foundations, sheet piles, any kind of pile, civil works. Specifically, these ones are in Canada, the ones on the right. We did a couple solder piles, which is basically a cast in place pile with a reinforcement that it will be linked to the structure. And the other ones on the left, we have a load test, similar to what Charles was mentioning before. That one was in Kelowna. We were just trying to understand how deep we need to go with the CFA pile. For that specific project, we went up to 45 meter deep CFI pile. We have to use a different kind of tooling just to get up to there. second deepest pile, CFA pile that it has been done in Canada so far. And the one on the bottom left, it's a project that we did it 2 years ago, Grand Turks. We're just working with a Carnival cruise ship. We're just trying to do some monopiles for the bowler that they're using for the longest, I think, ship, which is the Mardi Gras right now. And we did as well as a couple underwater ship wall for protection of the current piles, the existing pile they have at the pier. That one on the left, and that's something that, as I mentioned, it depends of the size of the project you have in each place. That circular pipes that you have in there and the shape is for the LNG tank. Back up north in Canada, they're in Kitimat. They're building an LNG facility, and we have the pleasure to do the foundation through ground improvement using steel pipe piles, close-ended pipe piles. So basically, that whole foundation was 2,000 piles that we didn't use driven piles, up to 20-meter long each pile. The one in the middle, that's the project that I was mentioning to you guys. That was the second deepest CFA pile made in Kelowna. Reason being, as Charles already mentioned, we don't have a really good bearing capacity on the first 15, 20 meters. So after the geotechnical report, it was found that we have to get that deep to be able to have the building working. The one on the right and bottom left, those belongs to Turk and Caicos. That was the last project I just developed in the Caribbean. We did redevelopment for the South Dock Port. They wanted to build a new pier, which was built using the combi wall system with sheet piles and pipe piles. And then after, the whole idea was to build the pier. So the one that you see on the left is brand new. Actually, they're gonna open that up in a couple weeks from now. And yeah, this is kind of like a taste. I have several more that I would like to show, but time constraint, I won't be able to. But just to let you know that this is available. This is out there, and it could be useful. But as you will see, and I will just discover in the next couple of slides, and at the end when we get to the conclusion, you will notice that basically what clients, contractors, and ourselves are looking for is not to put anything in the ground that is just work. CFA pile will work, driven pile will work, maybe a micro pile will work, but the end result here is to find a cost-effective solution that will suit the client, that will suit you. And everything has to be done in the right process, which start with geotechnical reports, which is something that is key here. Something that I would like to mention before to jump into it is people underestimate the soil sampling. And that is the first step. If that is not done accurately and with care, it doesn't matter how hard and how truthful you are in your report. If you don't have the right information for the lab, everything else is not going to work. Okay, so now just jumping into the first technique that I'm going to explain. We have ductile iron piles. So basically, as you know, all these techniques are based on trying to get bearing capacity or friction from a structure, which this time is, imagine a column of steel or concrete, just to get enough capacity for your structure. That's basically it. For the iron pipes, the difference that you have is this is a sectional pile, so it's built through pipes. It comes with a 5-meter long section pipes, and basically they have a joint that it will get you up to your maximum length. It's a male-female connection, and the good thing about this technique is you don't need any specialized equipment. As you can see in the photo, an excavator can make the job. The only thing you will need is just the attachment that goes on the boom of the excavator, and then after you're good to go. So the other thing about this technique is, as you know, if you have ever been involved with piling, piles are always come in long, like fixed lengths, right? 30 footers, 50, 60 footers, you name it, depending on the design that the geotechnical and the structural engineer have agreed on. These pipes, because of the length, can be shipped in 20-footer containers. So basically, you can get all the needs of the pipes that you want in containers, which actually it will save you money. It's easier to transport, and not sure if you guys have been involved, but with the steel pipe piles, because it's a bulk that it needs to be carried for transportation, it's a little bit hard to get it. We understand that better when COVID happened and there was restriction of shipment and nobody just wanted to move. So this kind of thing, it helps a lot and it saves you money just from the purchase perspective. So right there, when you're traveling and bringing these pipes, you can get it cheaper than just bringing a steel pipe pile or even a concrete precast. So for the installation, as I was mentioned, basically you have a start, which is it could be open-ended or it could be close-ended. So it could be with a point. It's that way you're going to look for bearing capacity. And then after what you do is with a two-man crew. You don't need more than two. Two-man crew and your operator. Basically, you're handling each pipe, trying to reach your design depth. That's basically it. The equipment that you have on top of the excavator, it will just generate vibration, high vibration, which is going to drive it through until your design depth. Something that it could happen, and we are not um, extend to happen problems. Maybe you got a boulder, right? So you are not going to be able to extract it, but maybe you reach your bearing capacity before you get to the design depth. The good thing about this is as soon as you reach your depth and you get rejection right now, you cut the pipe, and that pipe that you cut, it can be used as the start point of the next pipe. So basically, there is a saving in there different from the steel pipe valves. When you cut it, and basically that's garbage. So you just have to sell it or do something else, but it's not reusable for the next pipe. With this one, you have that opportunity. You have the opportunity to maybe cut it, bring another point, restart your pipe, and nothing happened. You just continue your process over and over until you continue. There's two options. If you're gonna do densification, you only do the procedure I just showed it to you. But if you want to add capacity to the pipe, basically what you do is through a pump, you just pump grout inside of it, and you're bringing more bearing capacity to the pipe itself. There is another option. This was for bearing capacity only. These pipes as well can work as a friction capacity as well. The only difference between one technique and the other one is you switch your shoe, as you can see on the top left. Basically what it will do, it will create more room between the soil and the pipe. You do the same procedure, you drive the pile with the shoe till your design depth. Then after, you fill the gap between the pipe and the soil with grout, creating that friction that it will add up to the number for the final load. So the important thing about these three techniques, and just to clarify, is to try to understand better where to use it, right? Um, in some projects, in just to call an example on the top left, you don't have the room for it, right? Maybe you have to do a repair on your building, and the only room you have is like 3 meters. If you cannot just put a normal rake in there, right? You cannot just you can bring a micropile machine, for example, which is similar to whatever Charles just showed to the soil sampling. The problem with that is it's not cost effective. And second, you have to find the equipment available, right? Here, basically, you get an excavator, you switch the arm, and you start doing the same procedure. If you need to cut the pipes, you cut the pipes, and you make it in a fixed length, so you are going to be able to work it out. The other thing is on the bottom left, if you're in a situation that your foundation needs to be really close to an existing building or structure, you can get as close as 40 centimeters with this. So it allow you to get really close if you need to have like a foundation or any pad, concrete pad that it needs to be next to the building. You could do it as close as that, and the result is that you're not going to affect anything on the nearest structure. So that's again a possibility that you don't have with impact hammer, when you don't have with another vibrator, right? Which it can cause any potential damage just in the process to make the pile into the ground. So that's a good option to take into account. So as I mentioned, yeah, there is a couple advantages. The only one that goes against this piling works is the lateral capacity of the pile itself, the unit, is not a lot. It could be used for that, yes. How can you solve the problem? Most of the time, you group the piles. You make a group of piles, bring in more axial load capacity to the system, and then it will work, right? The only problem you could call it is your cost is going to increase a little bit because you need more piles, right? So that's when the whole estimating it will take care of. It makes more sense maybe to increase the diameter and go to the CFA pile instead of going to the ductile, right? So at this point, when you have that constraint of the lateral load, it's just best to start looking into potential options to see which one it will be your most cost-effective solution. So the next one is the fiberglass piles. Um, Installation-wise, and it's just the same as another driven pile, but it has differential on the material that you're gonna use to put it into the soil. The resistance, the expectation of low capacity is similar to the steel. Actually, it's higher. But the good thing about these piles is they have really good workability under corrosion. So when you have corrosion problems, when you have environmental problems that it will reduce the lifespan of the pile, this is a great solution. Basically, what it have is you could change easily from a lifespan of 50 years to more than 100. What you do is you do a little bit more investment on the purchase time. You purchase a material that is a little bit more expensive. The installation cost is almost similar to a driven pile. The difference is this material is lighter, so you don't need a big equipment to lift the piles. That's a saving in there. And the other saving is in the future. So as you are aware, most of the ports, piles that you use there, and bridges, when you're getting into touch with corrosion, you have to start thinking in maintenance. So all those structures have a maintenance plan, right? So you have to change the pile or cover the pile, or worst case scenario, which is the latest you want to get in there, is remove the existing structure and rebuild it. What happened in the island is, sadly, this haven't been discussed enough. And sometimes governments, clients, they need to get into the point to remove the existing structure and rebuild everything. So to try to remove those additional costs, try to look into this option is best. It's just to try to understand where to use it. So anything related to any marine works, docks, small ports, marinas, it's a great opportunity to use this kind of piles. It might look a little bit more expensive at the moment, but when you show your client that you're gonna have an structure that it will long last for 100 years and the maintenance is minimum, that's where the saving comes. So usually, majority of the people are looking for savings immediately, right? Because that's your budget. But just be aware that budgets always cover for maintenance, and maintenance is a saving that you're gonna keep. So invest a little bit more now, but save it for the future, right? That's kind of like the end result of the fiberglass valve. For these ones, transportation is almost as similar as the driven piles. You have to use a big vessel just to bring it over. Production, it take a little bit longer because it's specialized. Um, there is no risk, or the risk is really low when you're doing the installation, which is a driven technique, like impact or driven, or sorry, or vibration installation. Either or, it will work. The only thing is you need to have people who have experience on the technique. Of course, if you try to do this just with somebody who want to do it but doesn't haven't done this before, you have a good chance that the piles are going to be broken. So just it's just different from the DIP. DIP is you could have one experienced person teaching a crew of two. Trust me, after three piles, they're experts and they will be able to go. So it's less cost for DIP, for example, on the admin side when you need to have somebody present for every once in a while. These kind of piles, you need to have an expert or somebody who has knowledge full time just to avoid any potential issues, safety wise, quality wise. Now, this technique has been more developed here in Jamaica, as I believe so, and in some other islands, same in the world. The CFA piles. Those piles, basically what we do is we drill through whatever length or whatever depth you want to reach out to. Then after, as soon as your auger, which is drill that you have in there, you reach out to depth. Then after, you're gonna replace the soil that has been removed with concrete, right? After you take your auger out and the concrete and the pile is filled with concrete, you place your reinforcement after that. There is a couple things that need to be looked after the CFA, and the reason why I said an expert needs to be here is you need a mix of good things. Make the hole, do the hole is pretty simple. Anyone can do that. The problem is when you're pumping your concrete up, that's where the whole thing starts to change. If your phase of removing the auger out from the hole is too fast, you're gonna start to have problem because you're not gonna fill the hole with concrete enough. So you're gonna start to have holes, which means that your river is gonna be exposed, which means corrosion is gonna happen, which means you're gonna have an issue. That's the first problem. The second problem is you do the hole, you fill it with concrete, you have integrity, so your pile is completed, right? If your concrete provider is not good, if the concrete hardened too fast, your river is not going to go out. So basically, you're pushing your river cage down, and maybe you get half of the cage down, and then after you have an issue. The only solution for those problems is cut the river and redrill. So redrilling through river, trust me, it will take weeks. So that's the kind of things that you have to look after. You have to be sure that the concrete supplier is giving you something that you need, but the only way to be able to know is from somebody who actually know which concrete do you need, which slump do you need. If you have that, this could be straightforward. So basically, um, you guys can use CFA piles in, I would say, most of the structures on land. This technique is not useful for offshore. And for any technique, I'm sorry, for any structure I meant bridges, buildings, tanks, anything that it needs high low capacity till certain degree. The restriction that you have with CFA piles is the diameter that you can get up to. As I said, in the US and Canada, they have been able to reach up to 60-meter right now CFA. That's like the deepest CFA that it has been done in the world. But that is just related to the soil that they have in there. But when you want to get into a bigger diameter, which is more than 1.5 meters, you can do it. Then is when you switch to casting place piles. That's when you use to drill rig machines, when you have your drilling buckets, we have your core barrels. It depends on whatever is the soil in there that you switch to your tooling. But at least when you need to get up to 1.5 meters and with a single rig like this or an excavator, which I'm going to explain a little bit, you could get up to 35 meters, which is plenty, and it will give you enough capacity at least for a decent size building. Going back into the equipment, and that's the reason why as well we're bringing this. As you can see there, that's a drill rig, right? It's a specialized equipment that only works to build a CFA pipe. The good thing about the CFA, the good thing about the fiberglass and the DAP is for both, you can use an excavator. The only thing you need to change is the attachment that goes with the excavator to be able to build the pipe. So getting availability for an excavator is kind of straightforward. Most of the owners have excavators. So getting into that situation allow you to do this. Potentially you have the excavator, but you don't have the equipment or the expertise. The fact that you have the excavator will save you money, right? The expert will bring the attachment, the expert will bring the people capable to do it, but you're saving right away into the rental of an equipment that you already have. So that's an opportunity in there. The CFA also, and just to keep everything into the cost perspective, this technique is really good when you have a big project, several piles. Let's just call it more than 80, more than 60 piles. It makes sense, and it has to be deep and a good diameter. When you start getting it smaller, it's not cost effective anymore. At that point, your mobilization cost, the concrete, the river, it will make sense to start looking into a different direction and try to get another technique that it will save you money, right? So the technique is good, it will work, but again, you have to look after your scope. check that your scope, it will match the need for the money that you're going to invest, and then after it, you should be good in that point. Um, Looking into the three techniques a little bit, as you notice, the first one, you don't have to spoil, right? You just push the ground to the sides, you push your pipe, and you're done. Fiberglass, again, you drift the pile, and you're good. With this one, you're going to have to deal with the spoil management. So you have to be sure that you account for that. Most of people think that you do the pile and you're good, but then after when you finish your project, there is 2,000 tons of soil, and what are you going to do with that? Where are you going to dispose it? How are you going to manage that? And it's not just where and how much it's going to cost you to put the soil somewhere. It's just that take room. You only have a certain amount of room in your project. So if you cannot manage your soil in time, basically you're going to have an equipment like that on standby, and that will create extra costs that you don't want to have, right? So that's one of the, you want to call it disadvantage, but it's an extra cost that you have to take into account when you're doing CFA pile. As I said before, you need a supervisor. You need somebody who actually have done this at least a couple times. Projects are different because soils are different. It's not the same to drill to a sand. It's not the same to drill to a clay. The expansion, because the concrete is pumpable, right? So you pump concrete, so it comes with pressure. If you have a clay, most likely you're gonna have a bigger overconsumption, right? If you have sand, most likely it's gonna stay as you forecasted. So the good thing about have someone with experience working in those kind of projects is you are gonna be sure or close to what your end cost is gonna be. If you're not prepared for that, just get ready to open your wallet and try to put more money into it when you have like a 30 or 50% over consumption when you just forecasted and estimated with a 5, right? That can happen in this. If you don't know which soil do you have below, and again, going back to the geo report, if you don't understand what you have there before to get into it, right? You could lose money, or you could basically have to drop the project and say, you know what, I will try to do something else and I have to go because this is not worth it. So here, what I would like to do is to present you what we just have discussed against driven piles, which is the most used technique here in most of the islands, and other pile techniques, the ones that I just mentioned. So anytime that you have a double check mark, it means that the technique has potential to save money. When you have the X, it's probably it's not a way to go. It's preferable just to get away from that and just look into another option. Quickly take a look. When you check out the DAP solution, it's really good in majority of the potential projects you have. Basically, offshore installation, it would be preferable to look somewhere else. And when you have a restriction, not sure how that works here in Jamaica, but in Canada and the US, we have by law. So there is certain period of time and places like close to a hospital or close to a place that you cannot just create a lot of noise. You don't want to get this technique. The installation of it, it's noisy, right? It's easy to do. As you can see, there is a lot of potential for savings. But if you have those specific restrictions, don't select that. Just go somewhere else. There is another techniques that are available that it will help you out. Now, if you go to CFA, again, it's really good, but don't look for offshore installation. Um, Again, it could be effective against corrosion, but you have to be sure that the concrete coverage over the river is achieved. You could check that pretty easily doing an integrity test. If you do your test, you could check that the concrete cover of the pile is good, and you should be good enough. Most of the rigs, they bring a software, at least the Soil Mix, which is a brand of the drill rig, have a software named GenLut. That it will show the operator real time how your pile is building and actually give you a report right away. So that will give you a good idea on how the pile is being done. But again, that it wouldn't guarantee that with the time the corrosion it will affect the pile and it will need maintenance. Again, as I mentioned, CFA piles, they create spoil. You need to manage that. You need to understand logistically how you're going to put it, where you're going to put it. If it's contaminated soil, which has happened in a lot of projects, and you don't know until you get it out, you have to understand what will be the procedure to dispose that soil. And it's important because I have seen projects losing the 15% or 12% margin they forecast, just dealing with that. So that's an important point to account for. Um, Again, majority of these techniques are not really good with a low headroom option. So if you have to do a repair, maintenance, you have to do a reinforcement of a structure, which it was similar to Charles mentioned. When you have a bridge that it was meant for the 80s when it was like 5 cars, but now you're trying to do a bridge when you have like triple, double, and even though the cars didn't fit, that's where you have to start to look into it because you maybe need pallets below the bridge and how you're gonna get there that done, right? So that's the reason why, for example, a CFA rig is not gonna be useful at the moment. So you have to look into something else. And for the reinforcement piles, the fiberglass, again, no low headroom. It's preferable not to use it. It will be extremely hard and it's a lot of cost because you have to reduce the length of the fiberglass and it's a lot of cutting and a lot of joints. So it's really not recommended. Again, there is an issue and similar to what Charles explained. Some techniques have not been developed as much as we want. Like we have a lot of data for CFA. We know how a CFA performs in any type of soil, right? We might have the same for the DAP, but for some, as fiberglass, this is fairly new, so there is not a lot of data. And as long as you don't have that, most of the designers they're not comfortable offering it, right? Even if the technique is there, the numbers are there, they don't feel comfortable putting something in the ground and they don't have data to support it. That was kind of like the first step that happened when the whole piling thing started. And if you have something that correlates your numbers, which, for example, as Charles mentioned, when you have a load test or a dynamic test, you could check that your numbers make sense. And potentially, and that's the important of the test, just to clarify, when you are designing, you're basing everything on the results you're getting from the lab and the numbers that you put it in, right? But there is no better option to check your numbers when you're doing a load test. The load test, it will tell you how close or how far you were from your original design. And on top of that, it will let you save cost in there. Just imagine that you use a safety factor in there that it will tell you that your pile is 35 meters, right? Which it was kind of what we did in Kelowna. When we performed the test with the load the client required, oh Jesus, now we have to go to 42 meters. But it could be the other way around. Maybe you forecast it as a 45 and you only need 20. So you're saving 20 something meters or 10 or 5 of concrete, of time, of rebar that it will bring you a lot of savings. So the good thing about this is for you to offer, and that's always my advice for everyone, is you always want to price whatever your client wants, right? We are here working for people who wants whatever they have designed. But you have the right and the potential to offer an alternate. Always clients will be inclined to see something that it will save thousands, maybe a million. But this is the only way to be able to know. To understand what you have down below, to compare what you have, to know what you have available in your town, what your people is capable of. And the other thing about the data, and at least on the contractor side, is you need to know how fast you can go with your people. You need to know how many piles you're going to install. You need to know how many days it will take. Because if not, that will result in a problem. And you're not going to be able to know how fast you're going to get and what to offer to your client at the end. So basically, that was like a brief, good summary. I hope so for those three techniques. And the main goal that Charles, Louis, and we have mentioned is it is extremely important. It doesn't matter which pile technique you use. It doesn't matter how much equipment you have. If you don't understand what soil do you have down there, you're lost. You could, I can guarantee you, we could use any technique to help you out. But if you don't understand your soil, basically you're gonna start wasting money. You're gonna throw money to a technique that maybe was not the right one. Maybe you could save there $1 million that it was your revenue. And if you're not doing that properly and take the time to get into it, basically you're losing an opportunity. All of this is just an opportunity to improve. just in cost. And as I mentioned before this meeting to couple people, I have been working in several islands in Trinidad, Bahamas, Jamaica, yeah, a little bit. Not right now, but in those places, you know that you could find people who are capable, people who are willing to learn, people who has the knowledge, but basically they are not getting into it because they don't have this. They don't have the information to support the country. And I believe the information is out there. It's just that we need the people who are looking into that get involved. People who are young engineers, people who are working in the industry, start doing more of this kind of events, but as well to try to incorporate things that they seems to be not aware of. And again, it's not just for the sake of learning, it's not just for the sake of experience. At the end of the day, all of us, I believe so, all of us, we work for money, and clients work money to be saved. And we want things to be operated in the best quality performance to get a good end result. So all of this is available. You can have any expertise working for you guys. Seeing through the process is best. And the other thing that I would recommend myself is just to have a teamwork. This is not just somebody here coming and say, do this file, or just the geotechnical engineer saying you have to go that way. When you guys meet the right people, the expertise, you can get a better solution. When the geotechnical, structural, even though the superintendent of a site meet, that's where you get the best solution. That's where you get your end result, and that's where you want to go. So I really hope you guys at least maybe not learn something new, but same something that it will just save a couple bucks here and there. And if anytime you have a question, I'm really glad and happy to answer if I can. If not, you can reach out and I can just do my best to answer your question. So thank you for that though.
Thank you very much for that presentation, Elbo. Very interesting. I know for some of our projects we have used fiber reinforced piles and BIP piles. For example, at Princess Hotel, we did 400 piles for the overwater structures, fiber reinforced piles. And another project that we had worked on in Ferry, we used about 67 BIP piles out there. So definitely opportunities to use these types of pilot methods. And I hope you all found that presentation informative. We've gone on an interesting journey today from geotechnical failures and the importance of site investigation to innovative soil stabilization techniques using these geogrids from companies like Tensar, and of course, distinct piling methods that can be implemented on a series of different types of projects. And I hope you all have found the information put forward here today helpful and useful for your future project. Next, we will have a short video from CGEL to play, and then we'll move straight into our panel discussion that will be headed by Mr. Julian McMorris, where I know some of you are probably burning with questions. At that time, you'll have the opportunity to, harass these guys up here and drill them with all of your questions before we leave out here today. So thank you so far for your attention and patience. We'll first start with the video and head straight into the panel discussion.
value integrity, efficiency, open communication, inclusivity, and team spirit. We encourage innovation, collaboration, and growth and development within a supportive environment. We aspire to foster leadership and sustainable success while setting benchmarks for value engineering in the region. Our geotechnical expertise spans multiple Caribbean islands, including Trinidad and Tobago, Grenada, St. Vincent and the Grenadines, St. Lucia, Dominica, Montserrat, Antigua and Barbuda, St. Kitts and Nevis, Tortola, Jamaica, and also Guyana. Consulting geotechnical engineers. Discover the strengths beneath. Build with confidence.
All right, we'll now start our panel discussion that will be headed by Mr. Julian McMarritt. Please join me in welcoming Mr. McMarritt.
Thank you, Victoria. On in the morning now, and we're probably ready for lunch already. But we're going to try to kind of challenge these guys. Thanks again, everybody on the panel. For a great presentation. Work with Charles from a long time ago. So I know everybody will have questions. Particularly, I hope some questions will come from the students, but there's been a lot of information presented here. I can kick it off. I don't know whether there's a microphone that's going around. I'll start with Tensar. One of the things that I think, we've used the geogrid at Princess as well. One of the words that gets thrown around sometimes is geotextile and geogrid. For the students, I wonder if you could give the difference between geotextiles and geogrids and where they're used.
All right. So I guess the best way to describe that would be to show you exactly what is the difference between one of them. So you can see here is geotextile is just like a fabric, and the main purpose of that would be to filtrate. You have one soil of one graduation, and you have a soil with a different gradation, and you can use this to prevent the contamination between them. You can use this to promote um, filtration through the membrane, and those are mainly the use of them. Um, in the past, long, long, long time ago, we used to use them as a reinforcement because that was the only thing that was available in the 70s. Not so much today. There's some high strength fabrics out there, but all of them depend to create long, higher deformation to achieve the tensile strength. All right. Um, with the geogrid, you actually what you do is to interact with the aggregate to change the behavior. When you change the behavior, you change the properties, you change the conditions of that soil, how it will act during the formation or loading conditions. But that's the mainly difference. Did I respond to the question?
Just to add to Luis' definition that was really good, geotextile separation. You use it just for separation purposes. If you use it for reinforcement applications, used to be the word for that type of application for reinforcement, then you will need to mobilize a lot of deformation before the geotextile comes to full extension. So you have full tension after deformation. And that's why the technologies move for stabilization. The technology move for this type of application for the concept of soil stabilization. It's not reinforcement. Here we're working at tension, so you need to mobilize the full tension of the element, and before that you have some deformation that will happen. Here, instead of working at tension, you are just providing lateral confinement, similar to the images that Luis shows for the triangle for the pool table. You are just confining the balls right there, and then you can build a pyramid because you are confining at the bottom.
Great, thanks for that. Any questions from the floor? Go ahead, a question here in the front table. Up here.
All right, good morning, everybody. My question is from Mr. Allen. He mentioned that his clients his clients would use raft foundations as opposed to piles. And I want to know if it's a matter of cost or preference or whatever it is.
All right, thanks for that. It all depends. Most clients, for them, profit comes before everything. Right? So cost is the main factor in terms of what solutions can be done as quickly as possible at the least cost. So as I mentioned before, piling rigs are not small equipment. And sometimes even the weight of these pieces of equipment requires special preparation for them to even move on the site. Right? And if they're not, metal track mounted, or you have to do a special road for them to move back and forth, right? And this is something that, even for me working with the Chinese 15 years ago, they think outside the box in terms of being able to access a site in different ways. They brought a piling rig, a push piling rig, to a site where they just push the piles in the ground that were prefabricated on site. And to my surprise, the guy just pull out the cord and plug it in the wall with this massive piece of equipment. But that equipment starts on a grid, and it could go 6 piles forward, 6 piles back, 6 piles back, and it could do a whole grid of piles without moving from its location, right? So that is ingenuity in the design process. So if you want to save cost, you want to look at what the size of the equipment. So most clients want to get the job done as fast as they can so they can sell units for housing or apartments as quickly as possible without mobilizing these size of equipment, right? For the younger engineers, I just want to make a note on the geotextile, or what we call a separation. For retaining walls especially, there are also some geocomposites on the market that some people believe that you can just use a composite without having the right aggregate behind the retaining wall. Right? So filtration means we allow water to pass, but not the particles of the thing. So if you have clays, they could get in and clog up the free draining gravel behind the wall. Right? I've seen clients spend millions of dollars in reinforcement and concrete for retaining walls and try to cut corners with the backfill. And it caused the wall to fail because there is no drainage. Drainage is key to retaining wall functionality and stability, right? So if there's cutting off corners, you can compromise your $1 million investment by just doing the wrong thing, right? And that's why we have standards and specifications, and they need to be followed, right? So I just want to make a note on that.
Thanks for that, Charles. Next question I'll take from the middle table here.
Hello, good morning. Great presentation this morning. I have two questions, one for Charles and one for Louise. Louise, for the geotextiles, right? How do they perform in our environment, tropical and marine? That's the first question. And then for Charles, in terms of doing site investigations for highly urbanized areas and where you may have buildings on all sides, how do you recommend that we or geotechnical engineers or engineering geologists do those? Thank you.
Just a quick check on that. Were you referring to geotextiles or geogrid?
Any of them.
Okay, so I guess the question was how this type of product behave or last on Caribbean environment. Okay, so let's say for the geogrid, the ones that are for the retaining wall, they're gonna work fine. Don't worry, they will be last there for 100, 200 years because the composition of them is high density polyethylene that won't interact with the soil or any chemical. Okay, for the roads that we have interact, the same. It would it would last more than what the road would actually last. Okay, so no problem on that. What about on marine applications like we have done here in Jamaica, Trinidad, uh, and the entire Caribbean, Florida, where we use your aggregate and materials here. So we have a special blend for that type of application where we use a Triton Xevier. This is it looks exactly like a geography, but the devil is in the detail. You know, it has some additional additive on the composite, so it could last the abrasion. It could last to UV exposure. It could last to the marine environment. To the point that right now that was a product that was developed between Tensar and the U.S. Corps of Engineers, specifically for marine applications. We learned a lot at the beginning, um, and right now it's just a standard procedure for construction of marine applications over there in U.S. And anything that you remember?
There are some geosynthetics that we use for retaining walls applications and sometimes even for roadways. And those are the ones made out of PET, polyester. If you are using a polyester product to reinforce or stabilize, you should pay attention to hydrolysis. Here, you mostly use limestone as a fill material for embankment, roadways, etc. And limestone, the chemical reaction, limestone, PET, that will accelerate the degradation of that product. So that's why for this type of environment, we use copolymer or high density polyethylene materials that will not degrade with the tropical environments, etc. PET is very good, but not for this specific type of conditions.
We have that family of products too, but we know the environment and we have this. We understand the soil, so that's a solution that probably won't come from our office.
All right. So second question, right? Site investigation for urban area. There are a number of government agencies represented here. I know that, right? And let's say we work in this area, and we see a number of high-rise buildings going up. Typically, what we would recommend as engineers is that there is a database from the government that keeps records of projects and new projects, right? 6-story buildings, 7-story buildings, already approved in the first place. In Trinidad, the Ministry of Works Design Branch approves all buildings, and they keep records of all reports. So the first part of the investigation process is what we call the debt study. So here comes your client wants you to tear down an old 2-story building to develop a 6-story. Right beside you is an 8-story building, right? And your client wants to have a 2-story basement structure as well, right on the boundary of the site. But you have an 8-story building next door. What foundations do they use? How deep can you excavate and without affecting settlements on that site? So we need to implement systems whereby engineers share information available. Before I came before I came home from London, I worked on Crossrail for a while for the Olympics in London. And 20 years prior, they had mapped out where the route was for that Crossrail line. Nobody could build in that zone. And the British Geotechnical Association has, you pay a fee, and you can access borehole information for as much information as you can as that preliminary data, right? So you would have at least, before you even drill a borehole on the site, you would have an idea of what the soil conditions are, so you could plan. Yes, you want to do some confirmation, right? But if you have some data, you could plan with the client and say, this is what is possible and this is what the likely foundation costs can be in terms of your preliminary pricing, right? The type of equipment that you can use on this particular site, right? And that's how you plan it out in an urban area. And then, if it's something where you're going to have to demolish a building, you demolish the building, you remove the foundations, and then you carry out your investigation. Then that's where you confirm the data and move it. You have to get information. So if you don't have any information, you have to find a way to get it, or else you have a big risk of how are you going to get this multi-story building to stand up, especially if you want basement. Where's the water table, right? I've been on many sites where contractor put in a price for a project, and as you go on site and start to excavate, water pumping out of the ground. Who's paying for that? Variation one time, if it's not in the report, right? So these are the things, especially for the geotechnical guys, the drillers. I know I have some guys who do drilling work. I don't play with my drillers. Borehole, the water level have to be measured in. And sometimes these guys, sometimes I catch them on site. Hey, that thing look like 10 feet or 12 feet. You drop a stone. No. We have devices to measure water level, right? And man could lose them job for that because that is my reputation you're playing with. So we want to do things in a particular way to keep the practice at a certain level. And you have to encourage your clients that you can't complete a proper design without the right information. Right?
I think that's a very important point, and we need to encourage our young engineers as they matriculate to ensure that they push back on their clients to make sure that things are done properly. Because a lot of times clients tend to snowball or try to roll over younger engineers, particularly on site. And it's important to hold your ground to what you know. Next question.
Yeah, good afternoon, everyone. Marlon Mendez here. I like the suggestion that Mr. Charles mentioned with regards to a database. I think that is very important. But my question is, in terms of the initial aspect of carrying out your project, normally you would order a TOR. My question to Charles is, what would influence the number of boreholes to go in a particular area? Is it based on your square area, height? What's your recommendation about that? And before that, Hebler, am I right? Yeah. You made mention of the deep pile foundation. But one of the challenges that we have is the cost that is associated, especially with the CFA. When you tell the client, X, this amount. But I want to find out, from your expertise and your costs, what's the cost percentage of the infrastructure, not the infrastructure, the superstructure, or should I say the entire project with the substructure? So what percentage of the substructure overall? Yeah. And there's another question I want to follow. Well, you mentioned it with regards to the stabilizing and improving the soil. You haven't made mention in your thought about that, but it would be good to hear your recommendation, particular when you order a geotechnical report. They would put, for instance, there's one in particular which I'm looking at, is the fibro displacement column. Yeah, you could give us shed some light on that, please.
All right. So I'm taking question one, right? In the presentation, we went through some guidelines of how we tackle the site investigation, right? I'm going to share that the presentation, I'm guessing, will be shared with everyone more like in a PDF format, but it's quite large. And it depends. I could tell you that the government or any client does not plan to do a project tomorrow and say, let's start. They go through a planning process. First, you have to have money allocated for this particular project, right? It just happens that in the Caribbean, it's just rush, 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 right? A site investigation takes time, and it needs to be planned, right? Sometimes a client may ask you to, is this site suitable? In that case, it's called a feasibility study. It's not a detailed design because there's no plans to investigate. So I may send you on site and say, boy, tell me if this site can be used to develop a 10-story building. I can just go on the 3 boreholes and give you some guidance on what I think could be possibly be developed on this particular site, right? However, when it comes to now, the buildings have been laid out, the architect has done laid out the roads and where the buildings they want to put the buildings and stuff like that. Then you get to a detailed investigation where get into the actual design requirements for each structure, right? So, for example, you're developing a housing development on the slope. Where you put the sewer? Is it central sewer or septic tank soakaway system? These things have implications on the stability of the slope, right? So you plan out the project properly, and then the structural engineer, the architect, and the geotechnical engineer sits in the room and come up with the most feasible layout for how much boreholes can be done, and we put a budget to the client. Where they put extra, and then say, "Oh no, too much," and take out two. Yeah, you already have what you want, right? The clients operate. But for the critical structures, you need to be able to, do a proper investigation. There's no two bones about that. 'Cause at the end of the day, anything happens on any site. The engineer there, see him, him. We don't use him again. You want to take that risk, right? I'm just telling you. And you live in a small country. See that man there? Yeah, him? No, we can't use him. My billing fail under him. You understand? When it has nothing to do with you, it's just procedure, right? So if you don't demand quality, you will never get quality.
Okay, so just looking into the two questions. The first for the percentage that the structure against the substructure, I guess that's what you're looking for. Um, Sadly, that's always a depends in both. Um, I would see something between the 10 to 20% and even more of the foundation, and that's the reason why Charles has mentioned that, and all of us have mentioned is that's a really important part of getting things done properly. If you fail under 20%, 80% is gonna go crash right away. Um, I say it depends because sometimes making the pals it's not a big cost impact if you have a high end building on top of it, right? If you have a simple structure which have no top finishing and it's just pretty simple, the percentage could change, right? So it basically depends on when are you looking and the amount and the loads and the height, but you could look into something around 20 to 25% easily. And again, that will change as well from country to country. The resources you have here in Jamaica, they're way different from whatever you have in Canada. Concrete prices maybe in Canada are lower. Potentially steel prices here are higher because you have to bring it from far, bring it to the port, and then do the transportation. Maybe the amount of transportation that you have in Vancouver, it's way easier and cheaper. So it will depend, but ballpark. The second question, you talk about the stone columns, if I'm not mistaken. Vibrated stone columns. Yeah. So okay. So basically, when you yeah. So basically, when you have always options that I mentioned. One option is the soil improvement. Soil improvement by itself, it brings different solutions. One, if it's stone columns. Other one, it will be grouted stone columns. You could do wick drains. You could do dynamic compactation. You could do soil processing. There's several, right? The difference are based on the design first. There is couple or several soils that you cannot do a soil improvement, or you could, but it will be way too expensive, right? And basically, what you look for in is to try to get a technique that it will help you with the bearing capacity. When you're using ground improvement, you prefer to use that in sand soils. Why? Because you're replacing the sand for a gravel. Basically, that's what you're doing. Or you could replace it with grout by itself with no reinforcement inside. And what you're doing is pushing the ground to the sides, generating densification, but at the same time, you're replacing a type of soil with a better one, bearing capacity wise, right? The difference will be that in here, it will be a little bit less cost effective because you need a specialized equipment, as Charles already mentioned. So you have to bring it over. That's the first thing. Then after, most of the time what designers will do is they create a transfer slab. So basically when you have ground improvement, there is no actual physical connection between the structure and the foundation. Basically the transfer slab, which the design and the thickness, it will depend on whatever you have down there. It will settle or carry on the settlements of the building, but there is no connection. When you do piling, you have a connection, a physical connection between your foundation and your building. So you have to look into the two options. I would say in the Caribbean, you could do it, right? As long as you be willing to do the first investment of have the equipment in here. After you have that, it is, I would say, straightforward. But I will leave the design on Charles. But basically, you could do it. It's feasible. In the long term, when you're doing several, you're gonna have benefits, and it's widely used in Canada where I live. There's that's some sort of developments that they would prefer to go with the ground improvement best instead of the piling. For you name it, cost perspective, equipment availability, because the end result you're gonna have a safe structure design for the end purpose.
If I may add a quick comment, I have a few words here. Engineer solutions, cost effective versus conventional method, time efficient, carbon footprint reduction, overall performance and reduction of the lump sum cost for the full project. That's what we do. We evaluate the project or the application in comparison with the conventional methods. And then we look for different alternatives to meet the expectation by the consultant that designed the structural engineer or civil works, etc. And we look for ways to reduce the cost, the carbon footprint. You don't want to be going to the quarry, impacting the environment and all of that. Two quick examples. One, engineer, the moderator mentioned, our experience in the Paradise on the other side of the island. We help with the design of some foundations for the buildings, access roads, working platforms. Instead of undercutting more than a meter, maybe with platforms of 60 centimeters. And then we evaluated the liquefaction mitigation, et cetera, et cetera. All of that with the available soils, with the available aggregate, with the limestone that is in the area or the sand. Another example, Dominican Republic, Puerto Plata Carnival Cruises. There they needed an access road. That was the first stage of the project. They created an access road that took them 5 weeks, 5,000 and some cubic meters of limestone. And they experienced many, many failures on that road. It was over a swampy area, so the deformations and all of that, you are all aware of those conditions. They submitted the information to us. We designed an access road that was later used as the foundation for the embankment and commercial area. In our case, instead of 5 weeks, it was 5 days. Instead of 5,000 and more cubic meters of limestone, it was only 1,500 cubic meter of limestone. And we control the differential sediment. So that's an engineered solution, in that case for a temporary road that then was converted to a permanent foundation. But when I said engineered solution was because we were in communication with the geotechnical engineer. He provided some information and we were in position to hand you, to deliver you a solution.
I have one more thing to add, right? And this is a Caribbean problem, right? I'm always honest and open about things and how we do things. Who makes the rain fall? A simple question, right? Who put what's in the ground? Not me. I will go to meetings and a client will cuss me out because of the soil conditions that I find on a site. I don't create the soil conditions. It exists, right? And most times, what we do is that a budget is planned for the project before they even do a site investigation. So when the soil conditions come back, we have to use a pile. The geotechnical engineer never create this bad soil conditions. It existed, right? So, well, client, the budget will be X. No, 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 no. No, you is a problem, man. You don't want me to build this project, right? So that is why we have to use now innovative techniques, try and find solutions to fit in a budget. I have a project in Tobago. The project manager and the client, right? This is for Church's Chicken. Decides that they and the client, the person who's going to lease the building, the rental price has to be X. So they already set the budget for the project, but they want to put the Church's Chicken on a slope so everybody could see it, and you have to do car park. You have to match the levels to get to the service window. So, and they tell me we can have no retaining wall on the project, but the site on a slope, right? So you have a budget that cannot pay a design team, but you need a design team to get it approved. So you're setting up yourself for failure. And as a client-facing representative, I have to go in the meeting and put a smile on my face and smile. Yes, sir. No, sir. Yes, sir. And we know that the project will fail because the budget just is not enough money to build it, right? And these are the things engineers have to speak up and say, well, I'm planning this project. There's time allotted. We're in a political 5-year system. We don't know if the lights will remain green or going to amber. We don't know, right? But at the end of the day, right, if you're planning something, you have to put aside enough with a little extra to cater for the variability. The ground conditions are not normally the same, right? So you have to put a little extra and keep it there so that if you have to do something extra, you don't have to go back to the client and get them upset, right? So I just said that to say we need to plan better, right, for these projects.
So that we have probably time for 2 more long questions or 4 to 5 short questions, right? Go ahead here. Oh, sorry, the mic is there.
Mention something about data, but then I find in our space, the Caribbean, in Jamaica, in particular, sometimes it's hard to get data. So I was wondering if you found out creative ways to get data, because I have had experience on one of them being recent, where it was hard to get data to work on a project, to make a decision, but the data was available. I just could get, I don't know.
Well, the first approach I would say is that as a collective, we have the JIE, and that we have PERB, right? And that we need to make a stand in terms of even starting with your own government agency, in that what is the record system you have in your own agency, that all the projects you have done before, where are the records? Them dash way? Are them on a database somewhere? Right? I have backed up on multiple servers every single project I've worked on since 2001 till present. Right? And a reference system. Yeah, but hermits must know better than that. The more we share, the better each of us become, Each one, teach one, right? Each one, protect one. Each one, help one. If we all remain this way, the industry is not going to get better. What do you want? You want a better industry, right? And I can guarantee you and tell anybody here, the more you share information, the better you become. But you have to make that decision, right? Engineering is not well, we all want to make money and live a good life. But we can't compete based on the development of the country. So we have to decide, we have to put down our foot that I have no problem giving you any information because it benefits both of us. And we have to just see it that way. Right? This geotechnical thing, to get it right, we have to be able to work together to build the capacity to get the country moving forward.
Just want to add to what your question is, and just bringing an example from abroad. What Charles says is just so true. I think this should be an initiative that you guys have to have on the engineering perspective. Uh, Canada, as an example, all the companies have a data cloud based when you put the information that you share with all the engineers for the help of it. Like everyone should have access to that because it's not just making sure that you're profitable and you have the information. It will help for remove the failure. Like we have seen so many structures failing because you don't have access to that information and you have to make the call either way. Like you have to make the call. That's the end result of somebody who is in charge, an owner or a project manager or a director. That information it will be available, but only if you guys work together to bring that up. It happened on the military side, it happened on the private industry, but it's available. It's just that somebody has to take the initiative to start that, and then all of you have to commit to provide information into it.
Very good point. Question
Yeah,
now.
morning. Gareth Gordon. My query is mainly to the bodies, NAA and GIE. What are we doing regarding legislation, lobby? Because clearly this is an important um, issue towards development overall and resilience. Because, you know, governments would like resilience built into their economy, having sustainability, even when you have a natural disaster. And geotechnical work is critical. I don't know where the lobby is to get this into legislation, so to speak, because it would be important from a governmental perspective that these mass structures have some legislation towards them and having geotechnical built into that legislation.
I'm not sure there's anybody on the panel from GIE or the agencies. I mean, I can speak to a very good point in the sense that that push needs to come first from industry through the institutions like the GIE, as you mentioned, but it has to be continuous. Has
Well,
to be a continuous push.
well, that's why I presented to those bodies. Those are the bodies that need to advise the legislators of what the importance of geotechnical work is. I've seen firsthand government themselves bypass geotechnical work and cost the country millions. Mount Russell is a prime example of that. I was on that project, and it is a it is a bypass by even the legislator.
Right, right. I don't know whether there's anybody on the panel who wants.
Yeah, you guys know I'm not Jamaican. I'm not from here. But there is something that it's applicable to any country, and the start for your answer is this event, is this form. When you have people involved and when they understand what it comes after, is when the whole thing is start to be in motion. Next step is to be to the engineering society to bring this up, and it has to be somebody who has been pointed to be the person to talk to the government itself. Like it's there's no mean for me as a person foreigner to come and talk to the prime minister, even if I have relationship with him and bring this up, if the local people are not pushing through the right departments. For me, I think the right department here is the engineering department, who has to push this information through, let them understand what's the result that you're pointing out, which is going to be a disaster at the end, loss of money, loss of credibility, because at the end of the day, they're not blaming a person, they're blaming a country. People are not willing to invade with Jamaicans, maybe because the result that they're looking at is not good, right? So I guess the question is valid is just to have more involvement into the engineering society and them to take the lead and just take that to whoever need to make the call. Because as much as we want here to talk and to make a decision, nothing is going to change until somebody actually put the right hat on it and just go and fight for it. And that's just my
100% agree. And as I said, you need to keep this on the agenda continuously. We have our 9-day wonder, usual activities with everything. If you don't keep things on the agenda, nothing gets done. I have a quick question on the DIP. You were mentioning lateral load capacities aren't very great. Is there an opportunity to use inclined piles to deal with lateral loads, as well as how does it perform with tension load?
Basically, you could do incline with the pile up to 45 degrees. Usually, when you get up to that point, is when you're trying to do more like a slope stabilization purpose, but you could still increase the capacity just by changing and switching the angle by itself. Um, and sorry, tension. Yeah, sorry. And for the tension capacity, you still have a good amount that you could handle. I would say it's just preferable not to get, yeah. If you rely into it, it's just best to switch techniques and just be better.
Another question in the back.
Good evening, everyone. Question to Mr. Ilbert. Um, in regards to the fiberglass pile, in which condition would you recommend we use that, sir? And also, how would you bring that to the market, knowing that it's something that is new and you want to get clients to trust you? And
Well, as kind of explained before, the best case scenario for you to use it, or the cost-effective solution in there, it will be for hard environment conditions. So corrosion. So that will be to be used as a part of the port foundation when you have to do it an offshore solution. Piers, when you have to do a small marina sea, then it could be a good solution still. There is a couple examples of some villas that they're just being built offshore in some of the hotels like in here. Those kind of piles are good for that because then after you don't need to start thinking on any corrosion problem for a long shot. So that's a good opportunity in there. Um, Related to the how to bring it to the market, there is a couple options. Um, Most of the time, as I just briefly mentioned before, is you have to do the evaluation and take the time to get your end number. Most of the people say my base design is a H-driven path, right? And I'm gonna put a PVC sleeve, and that's my option, and that's it. You price that, but on your own, you price the option with FRP path, and you say, you look, if you go this way, you're saving 100 grand. Trust me, if a client see that, they don't care about the H files anymore. They just jump into the other one. The option after that is, as all of you have already said, you start to collect data. You have to start sharing the information. Come to seminars and show the results that you got. Look, I did this project. This is the result. The base price was 20, and I did it for 10. That's the only way to show your people and have somebody who has the knowledge to share the information, to sell it. It's basically to create a business development line based on that specific type of file. Again, the material is there, the equipment is there. It's just to get a touch and start to doing things. Most companies in the US and Canada, if they have the equipment, they build one file. They do a test. They get the information by themselves. It's a small investment for a company, but now they have data that they can show to the client. Say, hey, look, I did the test. Look the results. Look the numbers. Let's just work in it. Let's just work together. Louis, Charles, we all mentioned. Myself, I'm not going to be the only one bringing the brightest solution. I have to sit down with Charles. I have to sit down with another people and say, hey, look, we have the solution. We all win. Like the end result, I would say, is to get the win-win, right? Client win, I win because I sell the solution, but the country itself and everyone win because you have a new technique that it will help a bunch of people with different potential solution and not just the H file. Just for a quote, if you are not aware, but it might come, the words and all that is happening in the last couple months and years, they're bringing up the price for steel. Getting steel right now is extremely expensive. So you cannot rely anymore just on steel. if you rely on steel, your project budget has to come up as well. So basically, you have to start looking into other ways like composite piles. You have to look into different options that give you that availability to come into an end result that meet your budget, as Charles already mentioned. So we have that. It's just to get exposure as everything and have the results to show to the people.
Mr. Jones, do you have a question?
Afternoon, everyone. It's more a comment and the business of public data. We tend to blame the politicians and prefer talk about legislation. For me, has everything to do with data in the public sector. And we have a significant example in Jamaica. National Land Agency was the absolute worst agency for accessing public information um, 15, 20 years ago. Elizabeth Stewart took the agency. You can walk in here and find data on a 100-year-old parcel now in about 5 minutes.
Yep, very good point. Any other questions on the floor?
Good day, David Allen. Right, not so much a question, but I just a charge to the Jamaican Institute of Engineers to lead the process in terms of the data sharing, because I think that the public may not know all these things. They are ignorant as it is, not even knowing that they need a geotechnical engineering reports and stuff like that. But the thing, I think that even within this room right here, I know Engineer White spoke, Andre White, and we have other um, top brass of the GIE here as well. And I believe they can lead the charge really to get the data sharing protocol or legislation if we need that. And the whole system set out in terms of how this data will be shared, shared, stored, and make available. Thank you.
I have a question to the students. When you get your final year project or your research project, what data do you use to do this calculation? Are these real world problems, projects, past projects, for drainage, for site development? What do you use? Is the university providing you with data from industry?
I'm hearing no's, very silent no's from the corner.
Nodes? So no real world scenario
Okay, we have
to
one person willing to answer.
So based on my experience when I was doing my major project, it was very difficult to get information. You had to beg, beseech, and go to this person. You hear go to somebody else. Oh, I'm in a meeting. Come next week. So sorry. It was very difficult to get information and being completely
wow. One of the things we try to do is that when the university calls, we answer, right? And we provide soil data, right, an approval from the client who really owns the data to be able to get engineers to use real world problems to solve their projects. And that is where it's supposed to start. So we need to get university and industry together to find a way where we can share this data, even for the students' sake, so that they can start understanding what is a borehole log from in school. Yes, sir. I think I'll probably strike a key.
I agree, Charles, because sometimes we get emails and requests regarding information for university projects, and we do help.
Yeah, just to touch base with what you said, as in regards to getting the borehole log experience. When I was doing my major project for UTech, we knew what was a borehole log from in school. And yes, I do agree that some data is to be shared, but at the same time, you don't want to make us comfortable or make students now in school too comfortable with that here the data is at your hand, just do it. Because when I was doing my major project, I took a manual auger and bore 10 holes in Spanish Town around the area and went back to the lab and tested the soil myself brought it to my father, the director, the program director, and say, is this approved? And he sent me back to redo the test again, right? That's just to say that you want to ensure that engineers now coming up have, they don't just have information, but they have the knowledge of how to get these information outside of the elders here and more guidance instead of information, because even AI, everything is at the fingertips, but they still want persons, the younger generation, to have that knowledge, that base knowledge of how to get these. So it's not a matter of just giving out information and here, this is the soil information for this area. Use it to your foundation, but this is how you calculate the soil, coefficient or anything at all. And this is what you need to do. That's just my point of view.
Yeah,
On the whole
I
matter.
appreciate that, but it's a little bit deeper. What I was trying to suggest is that if Dr. Smith gives somebody a research project, right, a student typically would not have the resources to go out and get this data, right? So if I'm doing a lecture, I'm going to give you, let's say your research is to go and look at a building that collapsed in an earthquake 10 years ago, right? And you want to know, run the analysis based on the existing soil conditions at that site, based on the foundations that existed on that building. We have some information that you could run and do a model for your SIP, Special Investigative Research Project. They can have some information to produce, right? Not to say that going to do the work, I'm just saying that sometimes as a student, you want to be able to use real world problems, come up with a solution in your own way, right? So what at UWI, that's what we do sometimes in St. Augustine. We give the students some data, but they would know how to get it and go and do the work. So I understand that. That's a question I'm asking for the student.
There
Thanks for that.
is,
I think we probably have time for.
yes, there is one question from the live stream, and it says, is the geograde and gravel raft applicable to roads that are susceptible to liquefaction? The geograde and gravel raft, is it applicable to roads that are susceptible to liquefaction?
Well, definitely, yes. Yes. Keep in mind, when we do a gravel raft below the road, so the question was that if we can use the gravel raft, stabilize the gravel raft underneath of the road to mitigate liquefaction effects. The answer is yes. Have been used before in New Zealand, projects in Chile, and the Caribbean also. There's a project in Puerto Rico that was just completed a couple weeks ago that was addressed that situation. And again, basically, underneath of the road, it will behave different. It will protect the road that no oil sands coming through the pavement, and definitely will help the performance. So the answer is yes. Yes. So I guess that I want to address that it's not Herbert's solution. It's not Charles' solution. We have seen solution where the input from Charles take portion of what we do and combine with the technology of Herbert, and together you put a new solution. So it's not like a straightforward all the time, like a this or this. It's a combination of disciplines and technologies that made the most cost-effective solution. I guess that we have to make sure that we set our priorities right, safety first, and cost second. Okay, we have to make sure that we have our priorities first.
All right, thanks for that. I think we can close the Q&A here now. Can we have a round of applause for our panel? I'll hand you back to Victoria.
right. Thank you so much for that informative Q&A session. We have reached the end of our seminar today. I'd like to thank you all for coming, and I'd also like to once again thank all of our speakers, Helber Gutierrez, Charles Allen, Luis Velez, and Angel Andalo. I'd like to thank again our sponsors, Smith Warner International, Consulting Geotechnical Engineers Limited, Geolabs, and Tensar. I'd like to thank you all again that the options presented here today are very doable. Smith Warner and our partners, we're doing these types of projects highly. We have a lab now. Geolabs, as I had mentioned in the beginning, and we're excited and eager to work with you all. I would like to also invite any of the university students to stay around and speak to some senior engineers here, and also to encourage you all to stick around for some networking opportunities. Thank you so much again for taking the time. I hope that this can be a step forward in building a better